Okay, so let's continue with the Spark core program what we were looking into yesterday, right? I'm continuing with that. Okay, so yesterday after the class, I was just quickly showing you guys something. Maybe in order to answer the question, what some of you guys were asking, right? As such, we are just having the data in this format originally, right, in the file. When I was talking about the map or any other function, I don't want to bother about whether I'm using map or filter or any other function over here or any other method over here, right, to process the data. What I was just talking about is I have two rows of data in my file or anywhere else. I don't bother. The first part what we were keep understanding is this is the only part where I require your knowledge of knowing the arrays and tuples. Only this part I wanted you guys to understand. Maybe be it a file and I'm converting it into, or I'm reading it as an RDD, or be it maybe like a collection like this, anything you are going to handle, I don't bother. What I'm just trying to make you understand is, primarily when you have the data in your file or anywhere, it will be read like this actually. So this is what I was showing you guys yesterday. So originally the data is like this: Irfan, 1000 and Venkat, 20,000. Like this, the data is there basically. So how I was showing is like this. Maybe let me put like this. The record number 1 is like this. I'm going to put it in an array. The records, right? Let me very quickly put this, right? I'm having something like this. I'm having some amount like this. I mean, if name and the amount, the customer name and the amount I have like this. The delimiter could be anything. It could be comma or anything else I can have, but array will be separated with comma only. So this is the records I have from the file and I'm reading it. When you create an RDD, this is how it will be created originally. There are two elements in this array. This array contains element number 1 and element number 2, or record number 1, record number 2. Now what I'm going to do is, I can take this one record and I can apply a split function and I can convert this into array of columns actually. So this is just a record. We can't able to convert into columns right away. So what I'm doing, I'm applying a map function. The map function is helping me going to the first record and apply a split function and convert into columns. Then the map is going to the second record, applying the split function and convert into columns. So that is what is being done over here actually. If you look at this data, what I'm doing is, when I take the first record and convert into, by saying like rex of 0 will return me the first record. When I apply a split function on top of it, by saying comma as a delimiter, automatically it will convert into array of these values. It will convert it into, it will convert this record into array of columns actually. So that what I'm going to do is, I'm not going to do it manually like this, taking the first record and then apply the split function. I'm not doing it manually. What I'm doing, I'm passing this records RDD or records collection, which contains two records, to a map function. So the work of map is doing what, or filter is doing what, respectively it will act. So map function first I'm passing. What I'm doing, I'm telling a map, can you perform a lambda operation on this? Can you pass your incrementer, the right side x, onto this, whatever the two records that we have in this collection? This array holds two records. Map, can you pass on those record number 1 and record number 2 by creating an incrementer and an accumulator? Incrementer, can you go and read the first record? When you read the first record, can you apply the split function? Because I don't want to manually take the first record and apply the split function. I wanted to use a map with whatever the lambda function, lambda expression to do this. So can you go and split this data by applying the split function? So the map will do what? He'll substitute 0, 1, 2, 3 like that by using this lambda expression. and I'll apply the split function on top of it. Once I apply that, what happens? The array of first string and second string, whatever is there, it is considered as just an array of string, which will be converted into array of string. That means this normal string will be converted into array of string, and outer array will be still maintained. That is what I am going to do here. So where recs with calls equal to records with columns equal to this one. What I was discussing till yesterday, or for the past 3-4 days, I'm discussing about this part only. Okay, now I have splitted the data from rows to columns actually. That means I had only a row with string type. Now I have converted these rows into columns. So I am putting that into array of string again. But what is one challenge we have here is, I have all the type of this array of same type. Like there's something like array of string only I have. Everything is array of string right now here. And all the Irfan is also placed in a string type. The salary what Irfan is getting is also placed in string type. And Venkat is also kept in string type. And the 20,000 is also kept in string type. Now, what is the challenge I may get here is, this array of string is not a right candidate to keep the data of multiple columns actually. So I'm collecting more than one data set into an array. That is true. That is correct only. But array will support only homogeneous type, you remember. Array is a sequence collection of homogeneous elements. So when I collect like this, I'm finding one challenge here. What is the challenge is, the name is in a string type, I'm happy to have that. But the number is also in a string type, which I don't like to have. So since array has a capability of storing only one type, one data type, what I will do, I will prefer not to go with array here. I will say, hey, after you splitted the data into column 1 and column 2 for row number 1, and for row number 2 also you have splitted into column 1 and column 2. I'm happy to see this, but I don't want to retain in this way going forward. What I wanted to do is, I wanted to convert this array of columns into tuples, because tuple is meant for records. Records means what? A record with more than one column. If I want to really store records with more than one column of their respective data type, Irfan has to be stored as string, but this number, the salary has to be stored as integer. Venkat has to be stored as string. So I wanted to give a column type actually. I don't want to store both of them in a string type like this. What I want to convert them into respective data type. So what I do further, after proceeding with this, after split is completed, I will again pass this data to the map function, because yesterday we learned about what is map, what is lambda, we know about it. Again, we are going to create a lambda expression. And here we are going to say, hey, when you now iterate, when the right iterator or when the right incrementer, when he go and increment, what he will do, first he will access this element of this array. So the map function will say, I will go and take care of iterating on this outer array. And the incrementer, where you are there, right, you go and take this first element in your hand. Now the first element is not a normal string. Earlier it was a normal string, and it applied the split function and converted into array of string. In the previous map, I did that work actually. Now I'm going to iterate on this array of string. Now I'm going to consider this x, the incrementer, as array of string. And in this array of string, what I'm going to do, I'm going to take the first element. How do I take the first element? By giving of 0. By giving of 1, it will give me the second element. Then once I did that, I'll go to the second record. The automatically my accumulator and incrementer, the lambda function will take care of doing that. The incrementer will go to the second record and it will handle this row. And what it will do, it will do the same thing. X of 0, x of 1, it will take. Like this, I can take each and every element from that array and convert them into respective data type and put them in a tuple. So I'm going to convert this array of record into tuple. What I'm going to do like this, something like this. So where record 1 equal to, if I store this data in an array of, if I have the data like this, let's assume. This is how I have the data right now. What I wanted to do is very simply, I want to take this array of data set, this incrementer, whatever is going to take this data, right? It has to convert into tuple. How he convert is very simple. So where rec1 tuple like this. If I create another variable, how do I convert? I put a open and closed bracket. Inside the open and closed bracket, I will say rec1 of 0. It will give me Irfan, comma, rec1 of 1. It will give me that number of 10,000 or whatever. Like this, I can convert. Now I got the first type Irfan stored as string. The second type also stored as string because naturally it is stored as string in the array type. So automatically it will give me the same data type only. Now what I had to do, one more activity here is dot to int I had to give. So now it becomes what? It looks like a proper record with two columns. First column of string type, second column of integer type. But whereas we can't get that in the array when we store the data. When we initially splitted the data, we'll have all the data types, all the columns are placed in a single data type called string because string can accommodate any data. So I don't want to stay here for a long time. If I wanted to really perform some record kind of operation, like a table kind of operation, if I want to feel like I'm loading this data into a Hive kind of table, then I have to convert this array of rows, or I have to convert each and every row is of array type, array of string type into tuples. I want to convert. This array of string has to be converted to tuples. So what I'm going to do for that in a programmatic way, just manually I did this here. I taken the first element of the array, second element of the array and placed in the tuple like this. We have learned about tuple long back and I wanted you to learn the tuple very heavily. I told you guys, tuple and arrays are very important concepts. Okay, now I'm going to apply with a function like this itself. I'm not going to do manually like how I was doing. I want to array tuples for every rows. I don't want to see it as an array of string. I want to see it as a tuple. So I'm going to run a map function. I'm going to put it in a tuple. This bracket, open and close bracket represents a incrementer. When you go and increment, bring the data and put it inside a tuple. I'm telling like that. So I'm saying a incrementer, you bring the first column. That is the first column. This is the first column. Right now my incrementer is staying here and I'm telling incrementer, you take the first column, that is 0 of 0. Then you put a comma, take x of 1 dot to integer. Like this, I'm doing what? I'm going to this array as a first iteration, taking the first column as is as a string type itself. But the second column again I'm taking and I'm making it as an integer and I'm putting both of them into a tuple. So what I'm simply doing here is I'm converting this array of fields into tuple of fields. Array of fields, if I have, everything will be in a string type. It can be accessed only by index. But whereas if I convert into tuple, I can have the respective data type for each and every column. The first column can be string, second column can be integer. Now you feel like you put a data type also for the columns, proper data type for the columns. Here I can't do. Here it is not possible. So I'm just converting it into a proper tuple. Now this becomes a records with columns of type tuple. The array says I hold all the rows. The tuple says I hold all the columns. So now Irfan comma 10,000 has been stored in first record of a tuple type. Second record as of a tuple type. Record or tuple both are same. We call the record in a form of or we will store the records in database table. We call it as a rows or records, right? That one in Scala we'll consider that as, or in Spark we'll consider that as a tuple. We call them as a tuple basically. Tuples or tuples or whichever you can call it as. What is the benefit I'm getting when I convert this into tuple of the respective data type? You just see here an example. If I go and perform an operation on the array of string data, if I have, I want to add or I want to give a bonus of 1,000 rupees for this employee. So what I do, I'll take this rec1 of 1 I will take, it will give me 10,000 or whichever. If I do plus 1,000 rupees as a bonus, what is the result it is returning? Yesterday I was showing this to you guys. It is returning what value? String plus number it is concatenating and giving me the concatenated result, not the result of 10,000 plus 1,000, 11,000 is not giving. So if I keep the data stored in a string type like this, if I keep the data stored like a normal string type like this by retaining the data in this way, if I don't convert it to tuple, the problem what I may get is not the respective data type will be applied. It will be all will be kept in a string type like this. Even the number will also be in the string and the name will also be in the string. So I can't able to make use of that more efficiently, properly. For that reason, what I'm doing, I'm converting into tuple. So in the tuple, I'm keeping the first column of one type, second column of another type, third column of some other type. I can convert like a record. This is the actual way how we store the final data or manage the final data in the form of records. Now, if I take this data, if I'm going to convert it into the respective type and store it into a tuple, if I access this tuple, dot underscore 2, I have to mention. What Johnson was asking yesterday, Irfan, what is this off 0? What is this dot underscore 2? Going forward, if I want to access this data to filter or to do something on top of this, what I'm supposed to do is I have to put dot underscore 1, dot underscore 2. I can't use 0, 1 because if we have converted the array to tuple now, the tuple can be accessed by only using the positional notation or by using the naming notation also. Naming notation we will discuss. Let's talk about only positional notation. So I'm taking the second element of this tuple, whatever I have stored over here as a tuple. I'm taking the second element of the tuple, whereas I converted the type into integer type. Now when I take the second element and add 1000 to this, it is giving me a proper result of 11,000, whereas this guy is not giving me the proper result. So the expected is store it as a tuple. Before you do some operation, you store it as a tuple. That is more better to go with, in order to handle it as a record of the respective data type. Did you understand what I'm doing here, guys? Only this one alone. Same thing is applicable for RDDs also. I'm just doing it in a normal collection data, but we can do it in an RDD also. The same map function, this will directly work on the RDDs also. If I have the data taken from the file or anywhere, I can convert in this way, which is an ultimate way we have to convert. So we can access the respective type in the respective way. That's the reason. Or if you want to store the data in a record format, this says I will hold rows. This guy says I will hold the columns. If I want to hold a row with a set of columns or a record with set of columns, we will be preferring tuple type. We don't stay with the array type itself forever. Okay, fine, Tim. This is just I wanted to once again add, and I'm keep talking about this tuple array only. Further to this, it's in your hand to go and try this out, especially the tuple and array alone. What is tuple? What is array? How do I access? Basically, our brain is only functional for working in a 2-dimensional data, not in the 3-dimensional data. Here, it is coming with the 3-dimensional data. We are having a 3-dimension over here, or more than 1 dimension over here. If I talk about only one record, our brain can easily understand this part. We are able to understand easily. If I take only one record and I'm talking about, if I'm taking one record and I'm converting into tuples, and when I perform some operation on that one record alone, right, we are able to understand easily. But when we iterate on this record by using the map function with incrementer and an accumulator and an incrementer and all, what we are doing here is the same activity. What we manually did here, I'm doing it automated way. By using some methods, I'm doing it in an automated fashion. That is the only thing I'm doing for more than one rows. One row means we can do like this very simply. But more than one row I have, if I have only one row like this, I can do all this operation very simply. But if I have more than one rows, I can't go and manually do like this. I have to pass it to a method like this, map method with lambda function and map method with lambda function. I have to use this kind of functionality over here. Otherwise, it is not a right idea to perform. So, where is my Rex? So let me give you this example, literally to understand the array and the tuple understand. Let me quickly mention this. Just try this out alone. Today I will put all this into our G drive, guys, for your reference. Okay. I know whenever I go with this Spark core and all, right, people will not show much interest. They lose their interest basically. But however, I wanted to go with this as well, and Once we go to Spark SQL and all, what they will make a mistake, people may miss the class and they don't prefer much of the Spark core. But what is the problem they'll do? They'll do the same thing for Spark SQL also, but that is the bread and butter. If you remember when Banu was telling, though she was very higher years of experience, the Spark SQL, what she was using for the particular programs, what you are going to see, right? And I'm extending that program I'm going to give you guys. That program was enough to get opportunities because it has a lot of business logics or business terminologies applied and all. Okay, so keep that in mind. This is for your data structure understanding. However, we are again getting one-time chance of learning all this. Not every time we will get the chance of learning this. And always when you go online or when you try to understand this, you can't understand. I'm trying to give it in a multiple representation. But not everybody are ready to maybe be patient. Fine, I don't want to bother about that. Okay, let me proceed in the way how I am going. Okay, so what I was showing here is.
So Irfan, hello.
Yeah.
Irfan, here since we give 2int and the data type is different, by default it is taking as tuple, right? Otherwise, without 2int, it automatically infers array. That's your understanding, right?
No. See,
if you remove the 2int, where x of 1 dot 2int.
Consider this data as a string. You can see here. This is normally taken as string. If I give 2int, it will take it as integer. It will cast it to integer. Like in a select statement, if I have a integer data in my table column, if I give cast of integer as string, how it will convert to string? The same thing is happening here.
Okay, that's what like automatic conversion from array to tuple it is considering. So without 2int, it is an array by default.
No. 200% not. You have understood in a wrong way. Just see this. What is your question here is, if I remove this 2int, will it become an array? That's what your question?
Yes, sir.
No, it is not.
Array of string.
It's not an array of string. It's a tuple. I'm keeping one open and close bracket here. That open and close bracket says I am a tuple. Regardless whether you are giving a 2int or not, you don't bother. He will create a tuple of 2 strings. That's it he will do. Is it a tuple or an array?
It's a tuple.
Okay. It's a tuple. This array holds records. This tuple holds columns. Earlier, when I was not doing this activity at all, when I was just splitting, it was creating as what? It was creating internally as an array of string. This array of string is converted into tuple of string comma string.
Okay.
Tuple is also can be used for storing the data set. Collection of data can be stored in a tuple. Or array also can be used for storing the data, collection of data. If you look at this this table, what I mentioned here, if you look at this table particularly, what I have mentioned here is, you see the tuple. Tuple will be used for loading the record or a record set of heterogeneous type 1, inceptus, 6. If I want to store what is the ID of the customer called inceptus and what is his age, if I want to store that into a collection type, what collection type I will choose? Do I choose array or a tuple here?
Tuple.
Why?
Different data types are there.
Different data type. That is what I'm doing here. I have a person called Irfan. It is a different type, and the salary is a different data type. But I'm storing it into an array of string originally because when I split the data, it will become an array of string only. This is how I'll first split my columns. First, I'll split my rows. The rex contains rows. Rex contains rows. 2 rows. How many rows are there in the rex? How many rows are there in the rex?
2 rows.
How do you say 2 rows?
We have a delimiter over there.
Okay, let it be. Delimiter or whichever. Okay, if you want to ensure there are 2 rows are there, you put the length of this array. It will show row number 1, row number 2. There are 2 rows are there. Why I need an array here? Why I need to put an array here? Because I want to hold more than 1 row. Each and every row is of what type? Same data type.
String type.
String. Originally I'm reading the data as RDD of string, array of string, RDD of string or array of string, whichever you name it. If I read it from the file and convert into RDD, it will become RDD of string. If I read it from a normal collection type like this, I'm just calling it as an array of string. That is what I'm first doing.
Okay.
So if I have an array which holds more than one rows, first row, second row, all are of what type? Row 1 is of what data type?
String data type.
String data type. How my brain will first see my students in front of me without thinking about what is his name, what is her name, or whether it is a he or she. I don't bother. I don't bother about the data type. I don't bother about the number of people sitting. I will just bother, okay, there are row number 1, row number 2. Row number 1 is of string type. Row number 2 is of string type. My brain will understand in the same way. The same way, first of all, the data will also be understood. Are you very clear?
Okay. Yeah. Irfan.
Okay. Now, what I'm going to do, I'm going to use a map function. What is the work of map? It will help you iterate every element. Select a select statement. I want to select the data from this group of records, whatever I have in an array type. I want to iterate on each and every element of this array. This incrementer will go and take the first element of this array when I write a function like this. Up to here I'm writing. I'm telling, hey, on top of the records, map function, can you help me do a lambda expression on it? So the left side will act as a brain, right side will act as an eye. The eye will go and see first the first row, like how the eye is going to see the first row like this. The same way, the first row of this array will be considered. Okay, now this X contains the first row, which is of string type. This is like this. The first row is like this. On top of this, what I'm going to apply?
Split function.
Some function called split function. So what it will do, it will take the first row, which is of string type, which is of normal string type, and it will convert into what? Once I apply the split, it will convert the normal string.
Array of string.
Array of string. That is what has happened here. It is splitting this data into 2 elements. Earlier I was having it as 1 row or 1 string type. Now it's split into more than 1 string. A split is cut down into 2 pieces means it will become again, a string is cut down into 2 pieces means it will again become string.
Okay.
Right? It is not going to become something else. It is, if I cut a cake into 2 pieces, it is also a cake, it is also a cake. String. Got my point?
Yeah, Irfan. Okay.
Now, the map function ran on all the elements. First element he went and ran. Second element he went and ran. The first element, second element. That is what we did over here actually. Records with columns like this, something we are writing here. So it converted the first row, first string data into array of string, second string data into array of string. That's what I'm mentioning as the inner array. The outer array still retains that. This is the outer array. It is still retained. Why? If I don't have this array, I can't say what? If I
have a column. I mean, in order to specify rows and columns, we are specifying.
Yeah, I can't store rows if I remove this array. So I have to have that array. And without this array, I can't specify what?
Columns.
I can't specify columns. But what is the problem I have here? If I give you a data of something like this, Irfan, 10,000, will you be storing it into an array or a tuple? You can store in both the types, but which one you will be choosing to store?
Tuple.
Tuple is the ultimate aim where you wanted to land. Why? Because I have heterogeneous type. But if I give you rather this data, if I give you the salary of employees, 20,000, 10,000, will you prefer to store it in a tuple or in an array?
Array of int maybe, or
array of int you will be preferring to store, not the tuple, because the data is of same type, like a employee number or salary, whichever. So that is what I mentioned over here. If you see, if you guys learn this, only the array and the tuple you can able to get whatever I'm speaking. So you see here what I did. If I store mute the elements like salary or amount, you see here, I gave an example. Now you are with me, what I'm speaking. So why we are keeping this?
Yes, I got it now.
Why we are keeping it in a tuple? For that reason. What I'm going to do now, I'm going to apply one more function to convert it into tuple. I'm not going to manually do this. I'm going to say x tends to, I'm going to put a bracket here, open and closed bracket here. This open and closed bracket represents I'm forming a tuple. I'm telling a incrementer. When you go and take this array of elements, right? When the right side x is going to hold this array of elements, right? Can you take the first element of the array and keep it as a first element of the tuple? Can you take the second element of the array and convert into integer type and keep it as a second column of the tuple? Like this, I'm telling. So take x of 0. X of 0 will take what here? In the first iteration, it will take what?
First row.
Irfan.
Irfan, yeah.
Irfan, comma, x of 1 will take what?
1000.
10,000. But 10,000 is of integer data type. I don't want to retain it as a string type. If I take this array of string data, it will show a string only basically. But I want to say, no, I don't want to consider it as a string. Initially it was string, I'm okay. But can you convert it into integer type? Like this, I'm telling, .toInt function. When I do like this, a tuple will be formed. This array of Irfan, 10,000 will be converted into tuple of Irfan, 10,000. But 10,000 will be of integer type, it will be converted. Right?
Got it, Irfan. Yeah, yes.
Now, it will be applied for all the rows. First row it will take and do, second row it will take and do. If I have 1 billion rows also it will do with the help of map function. Got it?
I got it.
Into an RDD, it will do it in a distributed fashion in the background. That is the only difference. That's it. Now I got the tuples of the respective data type. This can't be achieved in an array. You can't have an array with array of string, integer. You have to have either array of string or array of integer. But array of string only applicable for this case because Irfan can't be accommodated in an integer. So I'm storing all of them in a mere string format. Then now I made it as a proper type. Now this type is considered as what type? We call it as what type? We call it as
tuple.
Array of tuple.
Array of tuple. Okay.
Array of tuple. Array, this is array, this is tuple. This is considered as what?
Array of
array of string. This is considered as what?
Array of string.
Array of string. You got the point? So
yes,
why this is an array of string? All the rows are just a string type initially. After I applied a split function on each and every string, it becomes again an array of string because the split function will return an array. That is what is the reason I'm telling array of not just a string. I'm telling array of string.
Right. Okay.
Now I'm going to say array of tuples, not array of string. I'm converting this array of string into tuple. Minimum this one you guys have to know.
Yeah, I'm clear now. Thank you so much, Irfan.
Leave rest of all. Forget about rest of all. Just to only try to understand this. This is data structure. This is called data structure. And our brain is not prone for directly understanding this. That's the reason I always go with one record and show you guys. Rather than going with lambda and think about all this, just first try to understand with one record. After I splitter, what I will do, I will convert it to tuple. Okay, this is what I'm trying to make you guys understand for the past 3-4 days, right? But fine, spending some time on understanding this is not going to harm because this is going to be even applied in the Spark SQL in one methodology what we are going to apply. I remember one person, Nikender, okay? That guy have explained about it. We call this as reflection in Spark SQL. We are going to learn that. How do we create the structure of data using reflection is a question asked in interview. Or what are the ways you create data frames? They may be asking. This is one way, a costly way of doing, but still we can do. Using reflection, the concept of reflection. If you just go and see here, right? Spark data frame using reflection. Inferring the schema using reflection. How do you do? Create RDD, apply transformation, store that into a data frame like this. So if you just look at here, how do you convert an RDD into data frame using reflection? We are going to see that in our maybe like Spark program actually, in the document. But just I'm telling you, this concept, if you have to understand, you have to know how to split the data, how to convert it into tuples, how to convert it into tuples like this. Are we converting into tuples like this? Attribute 0, attribute 1. And we are going to apply a case class for that. You see here, there is a case class defined here. Person case class is defined here. Somewhere it might be defined. So how do we do this? Then only we can convert into data frame to write a query on top of it. We can directly write a query on top of it. Once you do this, there is one more step we have to achieve here. We have to create a case class. If I have to apply the whatever that reflection concept, this we are going to understand later. Again, I'm going to touch base on this. Case class employee of ID integer. I want to give a name for them. I don't want to access by position. Even here, I'm accessing by position ._1 ._2. I don't feel comfortable to do that. I can do with the help of the name also. So ID and the name, and ID and the or name and the salary I'm going to give here. So what I'll do, rather than calling this tuple directly, I'll pass this tuple to this case class. I'll say, can you apply a structure on top of this data? Like equivalent to what? I copy a data from a notepad to an Excel sheet. I'm doing like that. Now I made my data into an Excel sheet. It is equivalent to I populated the data in an Excel sheet. Now I can access the data by mentioning the name. Dot name, if I mention, it will show me Irfan. Dot amount, if I mention, it will show the salary. So like this, even we can access by mentioning the name. But we are yet to go to that. I will be soon going into that. We have that option even to do. If we are in a position to do this, we can simply convert this data into something called data frame. What is a very simplified stuff, what I was talking about, we are going to learn next. Where is it? I did not convert it. Once EMP off. Okay, I had to include that Spark SQL over here. Fine, let it be. I can convert into data frame by importing the implicits and all. There is something called we had to import something like sc spark.implicits like that and all. That is fine. Okay, there is some implicit library we have to import and do. Fine. So we will be going till this level and we will go to the next level later when we go to Spark SQL. There it will be very much helping you. So please concentrate on this and try to only understand how to access the tuples and the array alone. That's it, what I spoken so far. Okay, fine. So let's proceed further. If you don't have anything else, I hope you understood. Okay, let me proceed further. And again, I will make you guys do this, then only you will get the clarity. So far, you have seen over here, right? Maybe I just additionally shown today how to convert a tuple, how to create a tuple on top of this. So far, we are seeing only how do we have the data in the form of array, right? Today, I was just showing you guys how do you convert this array into tuples. So till here, what you see is, you will see array only created. RDD of array or array of array, we can call anything. Dot collect when I put, it is going to show you, it contains array of string. How do you convert this array of string into tuples is the one what I have shown you guys here today. Rather than storing all this, Arun Kumar also string type, Chennai also string type, 33 also string type, which is not advisable. So I am going to convert this respective columns into respective type. How in a table when you store, you will convert into respective type. These columns are splitted. I can access by position, by using the index, I can access the respective columns. But still the columns data types are not as per my expectation. I can convert it to tuple. In the next iteration, I can convert it to tuple also. But we did not so far convert it into tuple. We are accessing as an array itself and we are working on it. Let us proceed further on that. The tuple we'll be seeing more heavily later. Just today, what I have did is, when I started, I just shown you guys, we can convert it to tuple like this. Very simply by doing what? By putting an open and closed bracket after this splitted data, we will take this array element and put it into a tuple and place it inside a tuple and mention the data type of the respective element of the array. If I wanted to mention the data type here, I'll mention string, string, integer, string, and integer. Like this I'll mention. Or short and then integer. Like this I'll mention. That is a proper way of mentioning in a tuple. But whereas here right now we are dealing all of them as a string only. This is the understanding what you are supposed to have. Okay, let it be. Let's plan to learn the functions first. So what is the function of map function? Map function will help you to iterate on each and every element and perform some operation on it. Map is a higher order method. It can accept the lambda expression or a lambda function or any other methods as an argument. That's it. This is all about what map will do. Map function will do altogether, right? And map is one of the key function. It's like equal to a select statement. Okay, map is a method for performing or acting like a mapper. What we have seen in mapper, the same program or same methodology has been used in the behind, but without giving a huge maybe like complexity to us. What they did is they just created a lambda. They just told Irfan, you don't have to do anything. Just pass a lambda function internally. We will take care of creating the loop. We will take care of closing the loop. We will take care of help you iterate on each and every element of the loop on a given data set. Just you have to create a lambda function, and map will help you to perform a passive transformation on the data, and it will help you to transform the data and produce you the RDD with the mapped RDD. That is the transformed RDD. You pass the RDD of the lines of data in a string type, and this map function will go and take each and every line which is of string type and apply the length function on it using the lambda function, produce you the length as a kind of a result or as a kind of another RDD. If you want to realize the result, you go and iterate and see the result. That's what he says. Here, what map function we are using for? We are first iterating on each and every lines of data and splitting them into array of string. We are not retaining it as a lines of string. Originally, the lines is containing all the data, each and every row as a string type completely. After it's splitted, it becomes an array of string. The row is converted into columns of same data type called string, and it is being kept in an array. I don't have an option. I had to go in that way only first. All the column, all the rows, whatever is kept over here, are splitted for sure. But what is the problem I have here? Everything are formed as an array, and this is not the right way of storing heterogeneous data. Array is not a good candidate to store heterogeneous data. If I want to store only the salary of employees, I can store in an array. But if I want to store all this heterogeneous type, it is not preferred. Array is not preferred. But still, the split function work is to produce you all the columns in an array format only, first of all. Then you can convert this into tuple. That's a different story. But we are not doing that. We are holding in the array itself, and we are doing all the activities right now. Okay. So the rows are split into columns and kept inside an array after I applied the split. So here the map function is doing that activity. After I converted the rows into columns of array type even, I'm going to calculate the length of number of columns. I don't want the data type here. Each and every column could be of any data type. I don't bother. I want to know how many number of columns are there. So I'm not bothering to go with the tuple or anything. Again, I'm directly applying a map function once again saying, hey, this last map, you go to this first element of the array. This records or data set, whatever I have, go to the first element. This contains all the columns in the form of row. Go to the first row. Calculate the number of columns this row contains, this array contains. That is what I'm doing here. So it is returning another RDD. Map is a transformation. So it returns an RDD. This RDD, if you wanted to materialize and see, you are doing a for each println or collect or whichever you want. So it is showing all the column length. But we are doing an RDD operation. We are doing a distributed operation here. Right? This is all about map. Map can be used for do most of the activities what the select can do. The select statement, mostly whatever we write, we will be doing it in the map. Map is used for mapping the data, collecting the data, converting the data. If I use filter, the map will be, internally map will also work here in the filter also. What filter will do? Filter will go and take each and every element, each and every row from here. So after splitting, what is the data I have is like this. I have the data like this after splitting. What filter is doing? Filter is going to access this first row. And it is going to check for the column number 2. That is the Chennai. L of 2. L tends to L of 2. So I am writing a lambda function here. I am telling a incrementer L. You go and take the second column. That is Chennai or whichever. Convert it to uppercase. Like this I am telling. Once you convert it into uppercase, check whether that uppercase converted data is equal to Chennai or not. If it is equal, then return to your accumulator. What you have to return? You have to return true or false to the accumulator. This condition is going to return only true or false. Yes or no. Go or no go, it is going to return. If it returns go or yes or true, then you allow that corresponding record to be collected or to be considered in this main RDD. Otherwise, don't allow those records which are all made as false. So which are all the records that has an uppercase of Chennai is going to be collected as a final RDD over here. Which is of the same type, RDD of array of string only. When I collect now, it is going to show me only the Chennai data. But when I apply a transformation logic here, the filter is not for transformation. Filter is only for filtering by applying the transformation. After the transformation is applied, what is the filter I want to apply? I can apply. Then it will return only true or false condition. It is not going to transform the data and give it to me. It is just helping you to check whether the transformed data is as per my expectation or not. So I'm first doing a map. I'm splitting the data into columns. Each and every row into array of string I'm converting. Once I convert into array of string, I'm going and taking the second column and checking whether it is equal to Chennai or not. If it is equal to Chennai, then I'm filtering only those rows. I hope you are all with me in this, what you have seen already. Right? Right, guys? Okay. Are we very strict about doing only this way? Can't we do in some other way? We can do. Anything you want, you can achieve here. There is nothing we have to go by this way or that way. Maybe let me ask you a question. I don't want to do a map here. I want to take out the map, but still I wanted to see the same result. Can we see? I want to see the same result of what I'm seeing here without having a map function here, return at all. Is it possible to achieve that or not? I can achieve as well. The proof for saying the filter also includes map. Map is umbilical. Map by default will be applied in every functions, most of the functions, whatever you see. Internally, it will use map only to go and access each and every element. Then what it will do, it will show this character of saying, hey, I help you to do a filter operation. I do an iteration and all, as like how map does. But I will apply one more additional feature called filter. So this is equivalent to select and where class. This is equal to select class. Map can only do selection operation or collection operation. Filter will do both collection operation and filtration operation also. If you want to do, we can do. How do we do? Maybe rather than giving the map here, I am removing it. So what I missed here now, when I remove this map.
Split function.
I'm sorry?
No, split, without splitting, how does it?
Yeah, I did not split that now. Now the data is not in an array of string. It is in a what?
It's not an array of string, it's an array of string.
Very good. It is an array of string, just like that. So I'm going to apply directly on the lines RDD. Right? Okay, let it be. Let me show you first what's the lines RDD context. Lines RDD says I am an RDD of string, which is nothing but array of string. So lines dot collect, let me first do and show. I have a data like this first. Now, I want to filter only Chennai data. Is it possible to filter only Chennai data? This is a complete string. Normally I'm asking, is it a good idea?
No.
It's not a good idea, but still I wanted to achieve that. Because I'm not in a position to split this data because it is an unstructured data, let's assume. I'm just telling you. We'll go for this scenario especially. Wait for some time. We'll see such kind of scenarios soon. But if I have the data like this, I can't be able to apply the split function, or I can't do map operation or split operation, but still I want to filter only Chennai data. I can do that. So what I'll do, hey, filter. Can you have your incrementer go across each and every of this string? First, you consider this whole string. Earlier, what I did is after splitter, I told, can you take the first array and can you go and check the second column is equal to Chennai or not? Like this, I was checking earlier. But this time, I'm going to say, I can't ask you to take the second element or third element at all because this data is not an array of string. It is just a mere string. It is just a string data type. So what I had to do is, I had to use some other function maybe. I'll go and say, the incrementer, can you go and take this record and check for dot some other function. Like what Praveen was mentioning, dot contains. So L dot contains. I'm going to check for whether it contains, or L dot two upper of dot contains also I can mention. Like this I can mention. What does it mean? First, what it will do? The filter will go and convert all this data into uppercase. So for this, first, how do we have to understand this? Is like this. We have to understand. First, we have to take this row alone, one row alone. We don't want to apply this in a lambda. First, we take this one row alone. What the lambda will do, it will go and take row by row and perform this operation. It will loop and do. I don't want to loop and do. First, I wanted to take a separate record and try to understand. First, I will convert into uppercase and see. Yeah, as expected, it is working. Then I'm going to check whether the uppercase contains. I can't go and access a particular column and check. I have to check for this whole row whether it contains or not. So I'm checking whether it is containing Chennai or not. It is matching with Chennai or not. Like a like statement I'm putting here in SQL. It is returning what? True. We wanted true or false only has to be returned here, right? Then only I will allow those records. Still the filter is expecting the Boolean condition only. I got a Boolean condition of true for this record, first record. So the same thing has to be applied for all the records by iterating, by looping through, by using the lambda function. So now can we get the result the same way? When I do an action, am I seeing the same result? But not a best way to do. Because what if, or it is a best way to do in what situation? It is not a best way to do in our case, in our structured data case. Yes. So what Venkatesh is telling, if I don't have the data as like just Chennai alone, if I have A Chennai, B Chennai, C Chennai, it will bring those data also. It won't be very specifically looking for a particular column to bring the data. Whichever is matching with Chennai, it will bring. Whether before the Chennai I have some character, after the Chennai I have some character, it will bring. So let us assume like this. I want to get the data from a file or from a record. Anywhere I may have Chennai. The city can be Chennai. The headquarters can be Chennai. I have multiple columns in the data, or I have multiple unstructured data where Chennai is going to be present in which column, I'm not sure. Somewhere if people used some word called Chennai or not, I want to bring the data. I can just use, without splitting the data, I can directly go and check for which are all the rows that contains Chennai. For example, we do such kind of activities by taking our log. When I go and take this data, this log, which contains the data node log, let's assume. I have a data node log here, which contains information, warning, or anything, right? I can go and parse using the tab delimiter or whichever. But there are some cases I may have error over here, and here also I have an error. Sometimes this may be a warning and this may be the error. Actual error may be there, but it may show as warning or it may show as information, but I may have some error over there. I wanted to search regardless whether this column is error or this column is error or this value contains error or this value contains error. I can use the methodology what I was talking about. I use dot contains. Rather than splitting into columns and check the third column is error or not, I'll go and directly check this text contains error or not. Here I have an uppercase and lowercase together. So what I have to do? I have to uniformly convert all of them into either uppercase or either lowercase. You understood the reason behind why we can do this as well? In what situation we may do this as well? Guys?
Yes, Irfan. Especially if, like someone told that it is like a scrambled data, and if it is contained
Exactly.
another characters, yeah.
Exactly.
Probably,
So, this example is this one. Right? The literal example is this one. I have error as a category of this message or as a category of this log, and there is some error content inside the log also. Sometimes the category might not be captured as error. It may be captured as warning, but error might be there, or some text called error will be there inside my log, detail log. Anything can be there, right?
Irfan, I just want to validate one of my understanding. You told that if at all the data is more or less, or if it is a kind of a structured one, it is not a good idea to use the contains. Instead of that thing, you can go for a splits and is that because when I use for the contain approach, I'll not be using for any specific column. Instead of that thing, I am just converting the entire string. And I need to make it upper for the entire string, and I'm actually looking for a bigger data set, and it will impact my performance. Is that the reason, or anything apart from
performance will be affected? Second case is, as some of you were saying, right? I want to particularly look for Chennai. It will bring all the data, whether whichever is having a preceding or succeeding to Chennai, it will bring everything. A particular column value I want to check here. In that case, I'll go and do this. Regardless of whichever the column, whatever the value, if I found some trace of Chennai, bring that. I'm just telling here.
Okay.
I have to go further with this data to clean it up in a better way. But I'm first reducing from a larger volume to the smaller volume by doing this. Because I don't have an option to split this data. Let's assume in that case. Like a chat data if I have. If somebody is chatting, I want to know who are all happy customers, unhappy customers. First, I will use some keywords to understand which are all the keywords they are feeling happy, make them happy. Somebody may say glad to meet you. Somebody says like good morning. So whoever says that way, I will consider that customers as a bit of a happy path customers. With me? Okay.
Irfan, in that case, if it is a happy, we have a set of keywords connected to happiness. So in that contains, I can pass more than one key?
Yes, you can pass.
Yeah.
You have a lot of functions. It's not contains, it's not the only function.
Okay.
Okay, fine. So flat map. We are into the next function right now. Again, this says I have a map, but I'll do flattening operation also. Flat map is a function. It's a transformation, or it is a higher order method, which will returns the sequence of each input statement element passed to it. It will convert the data into a sequence of elements. What it will do, the flat map method returns a new RDD formed by flattening this collection of sequence. It's a very specific function we use for certain case. In certain situation, we may use this, not for all the situation. Especially the flat map will be used for handling the unstructured data. Unstructured data will be handled by using flat map. Okay, let me quickly talk about what is this flat map will do. We go to maybe like team build and all, if you remember, right? We used to go to when before the COVID and all, we used to go to some resort or somewhere and we'll spend some time, a day outing with our team. So if we go like that, let's assume we first go and sit in just in a random way with your friends or with your other close colleagues. We'll be sitting across. So Irfan is sitting, or Bala is sitting, Siva is sitting in the first row, and then John is sitting in the second row, Alan is sitting in the third row, I mean in the second row, and then Arun and Arivu is sitting in fourth row, along with maybe like somebody else like Vijay, like we are sitting, let's assume. This data, can we call it as a structured data or an unstructured data? So we are sitting in in chairs, sitting across with our friends here and there. Can we call this as a structured or an unstructured first? Is it a structured or unstructured?
Unstructured.
Unstructured.
Unstructured. Why? Unstructured is correct. But why? It's not structured, it's unstructured. Why?
It has a irregular column.
No, not for that reason it will become unstructured. Not for that reason alone it will become unstructured. I have 3 columns, 2 columns, and 3 columns. For that reason you can't say it is unstructured. Then, as Vijay, as you said, right, if I have some data like this, 1 comma, Irfan comma, age, 2 comma, Bala comma, age, if I have like this, the data. And I have, or I have a data like this. Is it an unstructured or a structured data? The data set what I'm showing. Or
Yes.
I'm having the data like this.
Structured.
Structured only, right? You can't call this as an unstructured. Somebody saying, hey, Irfan, since it does not have a delimiter, it has a delimiter, it has a space delimiter. So we can call this as a structure means why we are calling this as an unstructured. The first reason behind, yeah.
Doesn't have header.
I'm sorry?
It doesn't have header. I mean the column.
Exactly. So there is something called maybe like the normal forms are being introduced by card rule long back and all. Atomicity, consistency, integrity, durability, like that and all. Acid has been introduced. I'm not talking about all those. Forget about it. Just I'm telling one property of that. See, the record water I have over here, if I take the column number 1, if I take the column number 1 here, I will say why I'm calling this data as a structured data. The reason behind, if I take the first column and take that column to the next and third, and if I compare, hey, ID1, Irfan is belonging to ID1. ID1's age is 39. I can tell in that way. Or the second column, if you consider, ID2 is belongs to Bala, or Bala belongs to ID2. You can say that, right? You can relate with the key column with the other columns. But whereas we don't have an identifier here. We don't have a key identification over here or an identifier over here. Can I say Irfan? Irfan is the guardian for Bala and Siva. We can't say. We can't relate Irfan with Siva or Irfan with Bala or Bala with Irfan or Bala with Siva or anybody. But whereas here we can relate. We can say the customer ID 1 and his name is Irfan and his age is 39. Irfan's age is 39. Customer ID 1, age is 39. Or 39 belongs to customer ID 1 or 39 is Irfan's age. Like this, I can relate all these 3 columns in any way that I want. But whereas we can't relate here. That is the first criteria that makes me understand whether it's a structured data or an unstructured data. Most of the people will not think in this way. Everybody will say, okay, this is a proper way of identifying whether it's a structured or an unstructured. Always, when they look at the data, it is not in a proper order, then they'll say it is unstructured. No, not really. That is also a case, but first case we have to consider this one actually. This is one of the key case to consider. Are you with me, guys? Understanding whether it's a structured data or an unstructured data?
Yes, Irfan.
Right? Okay, keep it aside. Now, what I can do with the flat map? Like in our even in our team build and all, we do the same. The trainer or whoever the engage, the organizer will come and say what? Hey guys, enough you guys have sit and chatted, right? Let's start the event. Let's go and do some game actually. Let's play some game. All you guys, can you go and flatten? I don't want to see you guys sitting in front of me like this. Can you guys form a straight line? Can you form a single line? That is called flatten. I wanted to flatten you guys. The organizers stand in front of us and say, Hey guys, can you form a single line? Can you get maybe like, I don't want to see you guys in a jumbled way like this, unstructured way like this. Can you get converted into structured? So by flattening, the organizer will try to convert us into structured. That is what we are going to do now. So what it will do, I'll just place Irfan, Bala, Shiva, John, Alan. All of us will go and stand in a straight line. What my organizer will do, he'll come and say, hey, first line of people, you guys go and form a straight line. Then after that, you guys go and stand in the behind. And then you guys go and stand in the behind. Like this, I'll form a structure data like this now. How do I call this as a structure now? In an unstructured data of this one, can we put column names? Is it possible to put column names here? We can't. Can I put maybe like employee number 1, employee number 2? Nothing I can put. But here can I put employees? Can I put like this, a column name over here? Here I can put employees because I flattened them. I made them into structurized data. Now what I'm going to do, I may do anything else on top of this. Maybe I will say, guys, based on the technology, based on the project, wherever you are into, or based on the color of shirt you are wearing, I wanted to group you guys. I want to perform some operation on top of you guys. Like this I can say. So what the flat map will simply do, flat map will go and iterate on each and every row as like a map does. That's the reason it has the function called flat map over there. It has the function called map internally. But apart from that, what the flat map will do, it will apply one more function called flatten. What is flatten will do? Convert the rows into column. This is a single row of data right now I have. I'm going to convert it into a column. I will be pivoting it, or I will be transposing it, or I will be flattening it. We call it as a flatten. So if I pass a record to a flat map, the map will do what? Map will help me to go to the first row, second row, and third row. And the flat will do what? It will say each and every word, whatever I'm identifying with the delimiter or whichever, will be flattened, will be go into the next line. It will not stay here. The Bala will go to the next line. Siva will go to the next to Bala. Like this, it will happen. That is what is going to happen with the split, with the flat map function. So now I'm not going to take our lines data. I'm going to take our course data, what we had long back created, if you remember. Remember, cat mr data / courses.log. We had this data long back created, if you remember. I wanted to flatten this data. I want to keep Hadoop, big data, SQL, Oracle, everything in a single line. I can do that actually. So how can I do? I can structurize this data. It's an unstructured data. Do you agree, guys? Is it an unstructured data?
Yes, Irfan.
It's an unstructured data. No relation between the fields, or I can't keep a column name over here. Right? Nothing can be done here. So it is an unstructured data. I'm going to simply structurize this. So if I write a map function, well, maybe like courses equal to if you are going to access this in a local file system, you have to mention file : 1/ or // whichever is okay. I'll tell you why 1/ or // and all. And I have to mention this file name, right? Home XD user mr data courses.log. I'm accessing this data now. So courses.collect, when I do, it shows all each and every row as a single string type, array of string. First row in a string it has been placed, second row in a string it has been placed. Fine, I'm well and good. Now I'm going to say, take this courses RDD and apply a map function first. Let me try to apply a map function here. X tends to x dot split. If I do like this, what will happen? What is the delimiter I have to give in the split? Space. So when I do this and collect and see, it will give me what as a result? Can you guys tell me?
Array of string.
Array of string. In each and every internal array in a row of string, what will be there? Each and every of this value will be placed as a column. right? Like this. This is applicable when you go for what type of data. Doing this is good for what type of data. Map is for what type of data. Applying map is good for structured data. If I have almost same number of columns and all the columns are related, I can structure like this and I can access column number 1, column number 2, column number 3 like that. But is it the right idea to access as this is column number 1? If I try to access something like this, if I say access only the first column, dot map of extends to x of 0, I'm accessing. I'm accessing only the first column. It is going to return what? Hadoop, .NET, Hadoop, Spark, and then Spark. Like this, it is going to return. Is it the right idea to return this data alone and do a parsing, do an activity on this, and take the second column alone and do some activity on this? Is it the right idea to do? Maybe I don't have a second column in the last row, so it is showing the error. That is fine. This is not the right idea to parse the data because it is not a structured data, it's an unstructured data. So I have to treat each and every of this field individually. I can't keep them in a row and I can't say all these are first column. These are all first column, I can't say. So now I'm going to do what? I'm going to convert this data into structured format. Then I'm going to maybe do a map or anything that I want. So what I'm going to say, don't do map here. Do a function called flat map here. Like this I'm telling. So where flat map RDD equal to, like this I'm creating something like this. I'm simply saying what? Do a flat map. Map will do what? Map will go and take first row, like how we already did. Map will go and take the first row. Based on the delimiter, it is going and splitting, and it is going to keep this into an array. Because the string of whole data get converted into or get cut down into pieces. So that pieces has to be kept in an array of string type. So array of first element, second element, third element, fourth, fifth, sixth, like this I'm keeping. But now I'm going to say what? Hey, do a flat map. Do a map operation. Go to the first row. But do a flatten. Flatten means after Hadoop you bring big data. Everything you bring in a single line. Flatten it. Now this data is going to be formed earlier. When you do a map operation, how the data was formed, if you look at this. When you did a map.collect earlier, what it formed? It formed how many arrays internally? First array to hold first row, second array to hold second row. Like this, 5 or 6 arrays has been formed. To hold each and every row, one array has been formed. But here what flat map will say, I don't want it to hold all of you guys in a separate row or separate array. I'll form one array. I'll form one line. All of you have to go inside that array. So what it will do, it will form an array of string. It won't form array of string. It will say, I just form an array of string only. But inside that array of string, you have to come as what? Earlier you were there as what? Courses.log alone if we see. Courses.collect alone if I see. You have an array of this line. The second element of the array is this line. Now I'm going to say, form again an array only, but split each and every one of them as an individual element. Make all of them as a number of elements. So if I put courses.length, it will show me how much. Courses.count, if I put, it shows how much 6. Now I'm going to say, can you do a flat map on this data and form an array of string, RDD of string or an array of string? And if I count this, now it will return how many rows? How many elements it will return? Good, you have counted that. Venkatesh have counted that. Each and every one becomes an element now. Not each and every row will become an element. In the earlier case, each and every row is becoming an element. After I flattened, what it does is, it converted this row itself into individual elements and formed it inside an array. And subsequently taken this record also and formed it inside an array, inside the same array. So now if I go, it will show me 23 or whatever English have mentioned as such. Or if I do a collect now, you will be understanding. You have all of them formed in a single array. But where is the map data when I collected? I formed a map data and collected, right? I did not do a flat map and collected. Here what happened is, everybody are kept inside an array. Each and every row are kept inside an array. But whereas here, the row is flattened. This row did not made as row. Now I can't find this as a row. I have to find this as a column. A single column contains all this data. An example for that, if you want to see, is you can do a collect and then you can do a for each println operation. It is going to return as address. Fine, you can't see here. But whereas here, if I'm going to do collect dot for each of println, you are seeing everybody are standing in a straight line like this. That is the work of the flat map. The flat map will do what? It will go and access the first row and it will say, hey, you guys all convert into a column. Second row, go inside the same column of array. I formed an array, like this you will say. I formed an array. All you guys can you go inside and stand inside that one array because I flattened all you guys. I go into each and every record by mapping and I flattened you guys. So you have to come under one single array, like this is telling. That is the work of the flat map operation. Are you with me in what is the flat map will do? Flat map will form a new RDD by flattening the collection of sequence. The sequence which are all in the form of array will be flattened. Got my point? So the string whatever I passed is flattened. If I do a map, it will not flatten, it will form an array. But that array itself is flattened now. It becomes a single array of elements. Yeah, go ahead. Somebody was having.
Irfan, John. Irfan, I got, correct me if I'm wrong. Okay, when the data is an unstructured, as a process of converting that thing into a structured, in this case, a single column, we are using flat map. Assuming that here in this case, the data type of all my data is string. Now it is convenient that when I'm converting into a single column, ultimately it is storing in an array. So I can store homogeneous type of data. Assuming my data contain both the name and maybe age. If my unstructured data comes in that kind of a form, then
I will treat everything as unstructured data will not come in that format. If you have a proper types and proper values and all. See, in our case of unstructured data, if I don't have a connectivity between the data, somebody is using the chat like saying, hey, I am Irfan, my age is 39, like that. If I type, that will become unstructured basically, right? In that case, I have to treat name as a separate entity, age as a separate entity, right? And I'll be considering all of them as a kind of separate entity data set only. I can't connect. You got my point?
Okay, so what you're saying is that when I'm getting a data like that without any structure, I have to consider everything as an unstructured, probably everything as string.
Everything as a string. Then based on your filtration or based on your identification of data further, you can able to say like, yeah, I wanted to make this as a kind of a number or this as a kind of a string like that and all. That you can do actually.
Okay.
So kind of chat data like that and all, when you go, we have to pass it. We have to identify what type of data is that even.
Okay.
Okay, fine. So let me proceed here. Flat map activity is doing this activity alone. It converted the whole row, the first row, into a flattened data. This data has become up to here has got flattened. And the second data set is also flattened. Everything become now pivoted into a single field. Now whatever we wanted to do on top of this, we can name this as a course names. Or as like our John was asking, if it is an unstructured data or if it is structured data, if I apply a flat map, what happens? You can see this as an example. All will become integer type only. I mean the string type only. You see here. All are coming as a single field, whereas I pass a structured data. Even structured data also it will do. Flat map is just a function. I'm telling, hey, flat map, can you go and split the data and get it flattened? So it flattened as well. Then I'm doing what? Then I'm converting into toString and converting to uppercase or whichever I want, right? Or everything in the string type only. Here I can't perform a respective operation and all because everything is flattened and kept in a single array. This is a single array of data I have now. So it's our responsibility to go and check by using some functions like what we had and all, right? This instance of like something like that, or the class of this is integer or not, like this and all. We have to do some sort of operation for parsing this data further. But this data we don't prefer loading by this way, right? This is a structured data, so I'll directly go and access like a column by column. I don't bring everything in single columns. Got it? So it varies based on the need. We may be using the respective functions. Okay. Very specifically, if I want to go access that row and I wanted to hold that row and perform a flat map and compare, and then go to the second row flat map and compare, we'll be doing as well. That is where, if you remember, when I was showing you guys yesterday some hackathon, right? Here you guys are going to do that. Something like this. Chat or the respective type conversion. And you guys are going to do some operation of identifying only the key issues. I don't want to bother about all the stuffs and all what people have discussed. I want to apply some stop words, or I want to apply some keyword lookup, like those and all we'll be doing here. See, though the customer have typed anything in the chat, I don't want to bother about this good morning or my and is in the and all. These are all stop words. I'm only concentrating on some key thing over here. We call it as intent identification. I want to identify only the intent of this particular chat, why the customer is pinging me. I don't want to bother about what and all he is telling as a story. I can't sit and understand all the story, right? This you guys are going to do slowly. This is the place for just starting that learning. Okay, let me proceed further. So the flat map operation we can do to perform what? To flatten the data into a single field, into a single array. Rather than storing into multiple rows of arrays, we are converting all the rows, all the columns into a single column. That is the work of flat map. Are you with me, guys? So in our case, we did the same flat map long back by using something called flatten and all. If you remember our the trending code and all, right? The same thing we did actually. We did what? We first flattened, we tokenized all the columns. All the columns in the line we tokenized. And we did what? We used our mapper function. We looped through the tokens and we taken each and every token and we put one along with them, right? Like a big code we have written here, right? This code can be converted into a one-line code. This complete line of map method with a lot of looping construct and everything we used, we can convert that into a single line of code by doing like this. The same thing. What I was showing you earlier also, I remember, right? So I will do a flat map operation. Then I'll do what? I'll do a map operation then and say, hey, can you take each and every of this course and put one along with it? Very simply, I'll do like that. X comma 1. Map of x tends to x comma 1. I'll form a tuple here. I'm taking each and every element of this array and I'm converting into tuple by forming one dummy column, like 1 I'm putting. 1 is a dummy column I'm additionally adding. To understand how many times this technology occurred, this is what I'm doing here. When I do, this becomes what? What data type is this? Guys?
Array of
Tuple.
Array of tuple. I got an array of tuple here now. The array of tuple contains the first element of the tuple is the technology name and the number of times it occurred. We'll do the same, right? We'll be telling the same, hey guys, after you stand in a straight line, can you raise your hands? Each and everybody who are all standing, can you raise your hand? Now I can say what further to this. I formed an RDD, a paired RDD. This paired RDD can be passed further for some grouping operation or for some aggregation operation in that. I simply go and pass this into some function called reduce by key, which is a reducer. This is a reducer function we are yet to learn. And I apply a lambda function here, a simplified lambda function here, x plus or x comma y tends to x plus y. The reduce function we used, right? The same way I'm doing here. But I'm telling, don't just reduce based on the numbers. Don't count how many number of technologies are occurred here. Each and every technology occurred how many times? I want to know that. So what I'm going to do, I'm going to apply a reduce by key function. So in front of me, there are 85 people are sitting. Now I wanted to, you guys are sitting in front of me in 4 or 5 rows in a classroom, let's assume. So what I'll tell you guys, can you form a straight line? Can you go and stand in a straight line? Can raise your hands, each and everybody. I want to identify how many head counts are there in front of me. Then, can you guys go and form a group? Can you guys group based on the technology? And I want to know how many people are there in each and every technology. In front of me who are sitting, I wanted to take your information and I want to convert that into aggregated value. This is how I do. I pass to the reducer. This key and the value I'll pass to the reducer. And in the reducer side, what I do, I'll go and say, form a group of Hadoop, 1, 1, 1, 1. How many number of Hadoops are there? You form a group. And then apply a reduction operation on that. By the key, you form a group and apply a reduction. Reduction means what? Add all these ones. So it is going to return what to me? Hadoop, how many times the technology occurred? How many people are there in front of me in these technologies? Hadoop technology, 7 people are there. Spark technology, 2 people are there. Informatica, 2 people are there. I'm very simply achieving our MapReduce code by doing this. The same, this MapReduce code, what you have seen here, I'm achieving by this, very simply. Forget about this function and all. Forget about this functions and all. For now, you understand only the map and flat map. But if without using flat map, I can't achieve this in this case. Okay, forget about this reduce by key and all, Divya. I had to discuss about it. It is bit. It takes some time to discuss. Okay, forget. I'm just showing you just to show we can achieve this result and all as like our MapReduce code what we written. I just want to show we don't have to write a big MapReduce code like this. Spark simplified our life. I want to show that alone. I'm not teaching you what is reduce by key. Forget. Okay, guys, leave all this. Just consider only this data. What flat map will do? Flat map will help you to flatten the data. We'll do a map and then flatten. Map will help you to take you to line by line, and the lines will be flattened. The line of 5 fields or whichever I have, 5 elements I have, will be flattened into single line of element. So the map, if I apply, if it will give what? It will put all this data into an array of string. For a row, it will form an array. For columns, it will form another array. The map, if I go. But whereas flat map, it is telling what? I will only have a row array, and I don't form array for columns. Internally in map side, you formed column array for a column, right? I don't do that. I'll flatten it. I'll flatten all the columns into rows only. I'll keep everything in a row. Here it is telling Hadoop, Big Data, SQL, Oracle, Informatica, everything becomes a separate row. But whereas here it says all these together becomes a single row. This array will be removed by whom? By our flat map. The flatten will take care of doing that work in addition. Rather than forming it as an array by going into each and every line, the flatten will do what in addition? It will say, I will go to each and every line, but I will remove out this array and keep everything as a flat data. Because it's an unstructured data, I can't handle the unstructured data without flattening it, without making it in a single array. That is what the flat maps work. I hope you are with me.
Yes, Irfan.
Right? We'll see the application of this flat map and all later. But what flat map as it does, that's it. Okay.
Irfan, in chat history, the real application of flat map in chat, we could say is chat history. Whenever
example could be chat history or such kind of free form text, you can call it as.
Yeah.
Okay. Yeah. Map partitions. We just have to know what is this. We are not going to use this directly in our Spark core and all, because this is applied in the background already. I'll just show you guys. Okay. Let me ask you a question here now. Right. I'm having lines RDD. Lines dot collect if I do. It has around 5 rows or whichever the number of rows. If I do lines dot map of x tends to x dot split or something like this, I'm doing. Why I'm doing always split? Because first activity I must be splitting. That's the reason I'm going with the split. Dot collect when I do. It is just splitting and collecting the data. Fine. My question here is, how many times this map method will run? How many map tasks will run in this case?
5 times.
5 tasks. Very good. So each and this map will go and run on this row, and every row, and it will just try to perform some split operation and produce me. The map will go to the first row, which is of string type, and it will convert that into array of string by applying the split function on top of it. We'll go to the first row and apply the split function. Okay. Now I have an option called map partition option. The map function, see how many job I'm running here? One job. That one job has a map method. That map method is going to run 5 times. But actually speaking, in the background, how this map method will run? The map method will go and run inside each and every partition that many number of times as per the number of elements in that partition. So in order to understand that, what we will first do, we'll put glom.collect. The glom will help me to understand how this data is split into partitions. So in the first partition, I have 3 elements, 3 rows. Second partition, I have 2 rows. So what will happen basically, my map will go and run on this first partition. By taking the first row, he will process, one mapper is completed. Second row will take and process, second mapper is completed. Third row will take and process, third mapper. Parallelly, this will be happening in one side, and in the other side, one more mapper will go and run. He will run on this record, and this record. So 2 times he will run. So altogether, how many times? 5 times. As 2 separated instance, it will go and run. As 2 separated stage, it will go and run. Not stage. As 2 separated tasks, it will go and run. 5 tasks altogether going to run. But since we have 2 partitions, the 2 separated tasks will go and run in parallel. So I'm getting the performance here. Very, very simply. For a performance reason, I'm going to do this. Or it is going to do that in that way, in the background. In the background, you see the data is split into 2 arrays. Though I found it as a single array of data, and I say the mapper has run 5 times altogether. True, that is correct. Here what I'm saying, it is going to run 3 separately and 2 separately, but altogether it is 5 only. That is correct. But parallelly, I'm going to run 3 mappers in one side and 2 mappers in another side by splitting this data into partitions. So partition wise, the mapper is going to run. We are good. Are you clear with what I'm speaking right now? If I run a mapper, you told it is going to run 5 times. If I split this data into 2 partitions, already it is split into 2 partitions. That's the concept of RDD. Here also the mapper is going to run 5 times only, but parallel it is going to run. That is the only question here. If I split it into partitions, like even here, I have 2 partitions. One partition I have 3 rows. Another partition I have 2 rows. The mapper is going to run on these 3 rows as 3 tasks. Task 1, task 2, task 3, like that. And here also it is going to run as 3 tasks. I mean 2 tasks. But both are going to run in parallel. 3 plus 2. Together it is going to run. Are you with me, guys, in this? What I'm speaking?
Yes, sir.
Okay. Now, I wanted to have a control at this partition level. See, basically, if you run a program here, if I run a map function on top of these lines, can we have an explicit control on the partition? We can't. We'll simply say what? A map, you go and run on the data, all the 5 rows I have. I wanted you to process these 5 rows and split them into arrays of string or whichever. I don't say anything on top of this. It will do that work and give it back to me. But what internally it will do, actually speaking, if you go and see the UI even, you'll be understanding. It will apply something called a map partition RDD. It will go and create a partitioned RDD in the behind. But for us, I'll say it's a mapper operation is performing. Let's take this example. If I go and run this operation, it is going to have one collect operation performed here. If you go and see here, you can see something called map partitions RDD. It is not showing just a map RDD. It is saying map partitions RDD. What does it represent is, though we are feeling like, okay, this map method have go and taken the first row and converted into arrays, second row and converted into arrays, like that we are feeling. But in the background, how it runs, it will go and the map method will go and run on 3 rows parallelly, or inside the 3 rows, it will run sequentially one after another. And another 2 rows it will have in another hand, and work on this 3 rows and 2 rows parallelly together. On the partition level, it will go and apply. That is what this guy is showing. I'm doing at the map partition level. I'm running the mapper inside the partition. That is what is happening in the behind actually. It's not in our like visibility. It is happening in the behind like this. When I go and see the deep log, or when I see the UI, it is showing like that. But I wanted to say, let me take a control of doing this. I don't wanted him to do of his own. Let me take a control and do that activity. Like this, if you want to say, what you can do, you can go and create, or you can go and first do not a normal map operation, you can do a map partitions operation. That means what? See, if I just simply call here, guys, if I'm going to run a map method here, how many times this map method will run on top of these lines? You'll say what?
5 times.
5 times. But rather than map, if I'm going to run a function called map partitions function, so I'm going to say run a map partitions function, not map function.
So same 5 times with parallel action.
No. The map partition will run how many times if you ask me? See, map will run on every element of this data. First row, second row, third row, how many elements are there in this array, it will go and run, the map will go and run ultimately. But map partition will run each and every time for one partition. So we have how many partitions inside this data? If you look at this data set, we have how many partitions?
2 partitions.
2 partitions. So map partitions, if I say, how many times will run?
2 times.
2 times. It is equal to what? I want to iterate at the partition level, not at the elements inside the partition level. See, in order to iterate on the elements inside the partition level, what function I'll use? Map function or a filter function. Any function you can use, it will go directly and run on the elements. The filter will directly go and take this row and get it processed. But I want to say, don't go directly to the element. First, you stop at this partition level. You stop at this partition level map. If I want to say that, I want to map at the partition level, not at the element level of the partition. You are with me, guys? So we have a data set. This data set contains 5 rows. These 5 rows are divided into 2 pieces, right? If I perform some transformation or some function on top of that 5 rows, I'll always say, yeah, my function is running on all the 5 rows or 5 elements of that particular data set. Like this, I will always think. But you want to think one more higher level, not at the lower level of element level. Because if you consider any RDD, RDDs are what? Resilient distributed data set. RDDs spread across multiple nodes in the form of partitions. RDDs will be first formed with the partitions. Then inside the partition, what I have? I have the elements of the partitions. Elements are rows or whatever you can call it as. Are you with me in this? RDD, the whole data set, I'll define it in the name of RDD. But this RDD is subdivided into partitions, partition 1 and partition 2. Inside the partition, I have rows, I have elements or whichever. So now I could say, in our case, lines RDD, if you consider, how many RDD I have? Yes.
2 RDD.
1 RDD. How many partitions I have?
So 2 partitions.
2 partitions. How many elements I have altogether? Maybe
5 elements.
5 elements. So you have to see the hierarchy in this way. RDD spread across multiple nodes on or multiple memory area or anything in the form of partitions. Each and every partition will manage some data set. So far, what we were thinking, we will directly go and iterate on this RDD by using some function like map or filter or flat map or anything. And we will be only directly thinking about, okay, it handles the first row, let him process, handles the second row. So my map method is running 5 times. Internally, it runs in parallel or in sequence, I don't bother. Let him run 5 times. I bother in that way. I don't bother about this partition at all. I'll only bother about how many times the mapper method is going to run. Altogether, it is going to run 5 times. It is going to do all the operation. It is splitting the first row into array, first string into array, second row of string into array, third string into array. Like this, we are thinking. All the 5 rows got converted. But I have one more interim level called partition level. That partition level, if I wanted to go and do some operation, not at the element level. Element level, ultimately, I'll do the operation. But I want to hold at the partition level also. I'm holding at the RDD level, I'm directly jumping to the element of the RDDs. I'm not holding at the partition level. I don't have any control at the partition level. That will be internally taken care. Though you don't take any hold, though you wrote just a map function, what it does? It internally go into the partition and then it will go and perform the map. It will break this partition barrier and it will go inside the element of the partition and access basically. That is how my program will work. It will take care of going inside the partition and accessing the rows. We don't bother about this usually. But I wanted to say, hey, I want to take a control at the partition level. In what situation we'll do that, I'll tell you an example. But before that, I want to say, let me take a control at the partition level. I want to take the maybe RDD hierarchy. You see the RDD hierarchy, this is how it looks like. Now I want to say, I want to hold at this level. When I perform an operation on this RDD, it is directly going and performing some operation at the RDD, at the row level, at the leaf element level. I want to stay at here. Like this, if you want to say, you can use some function called map partitions. When I do this, what will happen in the beginning? This map partition will go and stop at what level?
Partition levels.
Partition.
How many times this map partition will run? 2 times.
2 times.
So this map partition is going to first take an incrementer. It is having an accumulator and an incrementer. The map partition's incrementer will say, hey, I will stop at where? The partition level, not at the array level. If I do a map here, what it will do? The map will say, this guy will say, I will go at the first row. But this guy is saying right now, since I used a map partition, he will say, I go at the first partition. I'll stop at the first partition. And inside the first partition, I'm going to run a filter function. See, whether you give this or not, it is going to run in this way only in our actual environment. But we wanted to take a control and see. I wanted to stop at the partition level and I wanted to do some activity. When do we do this? I'll talk about it. Wait for some time.
Irfan, it is very similar to a for loop inside a for loop.
Exactly. Yes, I have a two level for loop and a 3 level for loop inside, or any number of level for loop inside. Yes, it is equal to that yesterday what I have shown, I and j. This is I, this is j. Right? Okay, let it be. I'll come back. So I'm holding at the partition level. So this guy is stopping at the partition number 1. And inside the partition, I'm going to run a filter function. This filter is going to run on all the 3 elements and calculate whichever the length of the lines are greater than 20. Those lengths alone I want to filter. Once this filter completed for the 3 rows inside that partition, then the second element will be taken. What is the second element of this map partition? Nothing but other than the second partition. Inside the second partition, the filter is going to run. And the second partition is going to be what? The second time when the filter runs, it is going to have 2 rows. That's it. But this is how it happens in the behind scene also, even though I don't use. So that's the reason I told we don't use this regularly. Until and otherwise, if we have some key situation. Nowadays, we are not using or applying those situations also. Those situations we are not getting as well. Because we are handling all of them in the Spark SQL itself. But this is asked as an entry question even now also. What is the difference between map and a map partition? What is the difference, guys?
Map will run on each and row.
Element level.
Element level
Map
max.
will run at the leaf element level, at the each and every element of the RDD level. And map partition will run at the
Partition level.
Partition level.
That's it. So I have an RDD
Will be equal to the number of
2
partitions.
partitions with 5 elements, are each and every partition contains 3 and 2 elements or whichever, right? I have a feature, I have a function to run at the least data level or element level, or I can go and run at the partition level. In order to run at the partition level, we'll say map partitions. Only function we have. In the map partition level, we go and then we can anything internally to that. This is how it happens in the background also, though I don't use even map partition. I did not use map partition yet, but still it is showing what? Map partition RDD. Because It is applied internally. Internally, my Spark will go to first the partition level, then it will run at the element level only. But what we feel is when we use map, we are directly jumping into the element level, but not really. It will go and run at the partition level. We wanted to control that. We wanted to take a control of saying, hey, I wanted to run at the partition level. Like this, if you want to control, we can use this function, map partition. Then you go and run whatever the function you want inside that. Even a map function you can run, filter function you can run, anything that you can run.
Irfan, just curious.
One second, let me finish.
Yeah.
1 second. 1 more minute. Give me 1 more minute. What is the application of this? When do we use this? I wanted to connect with a DB, let's assume. Or I wanted to connect with Hadoop file system. I wanted to connect with cloud storage, let's assume. You prefer connecting for each and every iteration of the data, for each and every row, if you want to pick, you will be planning to connect to a cloud, or you wanted to connect to the cloud at the partition level. You want to connect to cloud, iterate to the cloud 5 times or 2 times. Which one you prefer?
2 times.
2 times. But I want to achieve the same result. I don't want to bug the DB or the cloud or any other file system. Number of times, how many number of times I have the number of elements. I don't want to do that. I wanted to do at the partition level. I want to bug my external systems at the partition level. So you prefer go at the partition level and connect with the cloud. The connection to the cloud and all you will make at the partition level. And the activity what you perform subsequently at the element level. So once for all, I will connect to the first partition of data and I pull all the first partition data and get it processed. Then for the second partition data, I will go and connect with the cloud separately and pull the data and get it processed. We have seen this multiple times in some other tool. Where?
Hive.
Scoop we did that. We mentioned the fetch size or records per statement, statement per transaction. You remember? It's equal to that. We can achieve something like that over here. So my direct question is, in this map partitions, we will have the connectivity establishment, or at the partition level, if you have a control, what we can do, we can say, hey, at the partition level, you go and connect to some external system, not at the element level. When I directly write a map function here without writing a map partition, if I have a connection inside the map function to a cloud or something else, then I'm going to say perform an operation of split or something on top of it. So for each and every row, the mapper will go at every row by row, right? For each and every row, it will do a connection. I don't want to do that. For one partition, you do one-time connection, get all the data. Then you perform the operation. Then you go for the second partition and do all the work. Like this, I can say. So the number of iteration, rather than performing 5 times the connection with DB or external systems, I'm going to do at the partition level, not at the element level. I'm going to connect. Are you with me? So at the partition level, I'm going to say, can you give me the data? At the element level, if I go and ask, can you give me the data? He'll give, but it's more iteration. That is where the map partition will be applied in the background itself. If you wanted to apply and see the example what I have given, we don't apply that in real time. This is being taken care internally itself by our Spark. So if you think always, guys, when I apply a map function or a flat map function, it is directly going and iterating at the element level. That is not correct. It internally goes at the partition level, then it will go at the element level, like how I wrote here. I'm explicitly writing it and showing you here, but this is what is happening in the background also automatically. The proof for that is what you guys are seeing in our, the proof for that is you guys are seeing that in our DAG, right? Very clear. The output I'm getting the same. Whatever the filtered output I'm getting the same, but I'm applying based on the partition level here. But this will be taken care internally. Fine. You guys can ask the question.
Yeah, Irfan, you almost answered that thing, Irfan. Either I'm using a map or a map partition. It actually internally going to assess in the partition level.
Yes.
But if I use a map partition, I can have a better control on what all the specific activity I need to do at a partition level, like one example you told.
Exactly.
Anything else we can think through, Irfan?
That is the only main use of map partition. As an example, if I explain.
Correct.
Partition level, I want to hold and do some activity, not at the element level.
Yeah.
Element level, we wanted to parse or we wanted to apply filter or anything. Obviously, we can't do at the partition level this activity. But partition level, we can connect to the DB or we can connect to some external systems, right? In those cases, right, the partition level activity will help you. With me?
Okay, thanks.
See, if I have to answer you guys, I have to come to each and every one of you and answer. That is element level. But I'll say, guys, let's form a group, 3-4 group. Each and every group I'll address. So you guys don't directly ask the question. You come through the group, or I'll come to your group and I'll answer. I'll iterate on that. So that is more better to manage. You got the point, right? Example I'm telling.
If on Vijay here, even though we run on partition based, inside the partition, how many times run? 3 times now. So
Yes, obviously it will run this many number of times ultimately. But at the partition level, when I hold, I do some activity at the partition level and some other activity at the element level.
okay.
Got it? So I do only 2 times the DB connection at the partition level, but I do an operation on the connected data and on the data that I brought forward. I do the operations in number of times as per the number of rows. I can't avoid this 5, obviously. No other chance. We have to iterate 5 times, obviously. But each and every time when we iterate on these 5 elements, do we have to go and connect to a DB? That is my question. That is where you can take this as an example to understand.
Okay. Map partition is run on parallel action or
Map partition is run on, I'm sorry?
parallelly. 2 partition is there.
Yes.
2 partition on parallel.
Yes. See, map partition will go and run. It will start the partition parallelly and it will start the thread basically.
Okay, fine. Thanks.
Can we control the number of partition? What Jnanavel is asking. Yes, we can do. By changing the number of partitions on the lines, by using some functions, what you are going to see called coalesce, repartition and all, we can control the number of map partitions. Got it, Jnanavel? We have to control the number of partitions here. Right?
Okay.
So
Okay.
if we go with get num partitions, it is going to show 2. If I go and say, now the map partition will run how many times? In the earlier case, how many times the map partition will run?
2 times.
2 times. Now the map partition is going to run how many times?
4 times.
4 times.
You can control, got it?
Got it.
Right? Yeah, that is how we can control. Okay, I'll take last 5 minutes of our time to explain about one more function, the set function. What is union? You guys know about it. Most of you guys know about it. So we wanted to operate on multiple data sets, right? What are the type of functionalities we can apply? What are the types of function we can use?
Joins.
Good, very good. Joins, set operation.
Union.
In the set operation, what all we have? Union, intersection, union all, or maybe like subtract, all this.
Minus.
And we have something called zip function in our Spark very specifically. Subtract is minus, okay? Minus in databases, here it is subtract, okay?
Right.
We have something called zip, we have something called lookup. All these are the functions what we have to perform operation between data sets. We have more than one data set in our hand. And an example for this is I'm going to get the data from New Jersey, Texas, and California. I wanted to marry all this data. How can I do? That is the question here. Or I'm getting the customer information and the product information and the customer detail information in 3 different data sets. How do I marry them? How do I operate between them? So
Union.
for the second case, I'll use join. That means customer information, customer detail information, product information. I'll use join. I use set operation for connecting the data from different regions I'm receiving. Okay. Or I'll do zip operation, lookup operation. The lookup you may be knowing earlier itself, but let it be. I'll talk about the zip and lookup separately. First, let me talk about the set operation. We go to joins also soon. Set operation first I'm going to talk. So very simple. I have some data set over here as EMP data 1 and EMP data 2 in our file system. Let's assume. Let me check whether I have the data. I have some data like this, and I have some data like this also. You can see Arun Kumar Chennai 33, the date of join, Lara Chennai 55, or both data seems to be same. Let it be. So now I'm going to modify the EMP data 1 to some other data set. I'm removing one of the row and I'm changing one of the rows value. Let me have one duplicate data. I have Arun Kumar is a repetitive data. Lara is almost seems to be repetitive, but the age alone is changed in the second data set, right? Or I'm going to have somebody else. And I have in the third data set something else. Something else like this I have as a data set. Maybe the last record does not contain all the 5 columns. I have only 3 columns in this data. Let it be. So now I'm going to get the data of employee data 1 and employee data from some external providers, external source providers. This is how I have the data. First data contains 5 rows. Second data contains only 3 rows. First data contains some list of values, and second data also contains some list of values. Maybe one record alone is duplicate between both the data sets, but rest of all seems to be distinct data. Now, very simply, what I wanted to do is I wanted to load this into 2 RDBs. I'm getting these 2 data from 2 different sources. I wanted to combine them. I'm going to store them in 2 different RDBs first. Now I'm going to do what? I'm going to combine both of them vertically. I don't want to combine them horizontally. I want to do them vertically. So like this, I want to combine. This is data set 1. This is data set 2. I want to combine like this. What I can do is simply I can perform union operation. So what it will try to do basically, the data of the first file and the data of the second file will combine together and it will form a data set of how many rows now? 3 plus or 5 plus 3. 8 rows I'm going to get now. So lines file 1 contains, it is a big story to discuss. We had to discuss more about this, but just I'm showing you the purpose of set operation, especially the union. I'm taking the union as a first example. I'm going to do what? Lines file 1 dot union of lines file 2 dot count. If I put, it will show me 8 as a number because it combined both the data. It merged both the data like this. Vertically it merged like this. Column to column it merged. Okay. In the first data set, how many columns I have in each and every row? Guys, I have how many rows first of all in this first data set?
5.
5.
Each and every row contain how many columns?
5 columns.
5.
1.
As such, we look into the data, we are telling 5 columns, 4 columns, whichever. But as
One
per the
column.
RDD, how many columns I have?
Only 1 column.
1 column. Very good. Of what type?
String type.
String. Array of string.
So this is the flexibility what we have in our core function. I'm talking about the core right now. The core has a big meaning here to use. When I do a collect on top of this, it is returning what data set? All the data combined together and it is returning me the result. Ashwini with 3 columns also returned. And the union when I perform, it will be considered as what you know as union all. Have you heard about union all? Couple of you know about what is union all. Most of you.
Yes.
Union all means what?
Same column.
Includes
Duplicates as well as
duplicates also. So I have a duplicate of Arun Kumar, right? Arun Kumar repeated twice. This Arun Kumar, this whole data, this is a 1 column if you consider, or 1 data set, or 1 row if you consider. This row is repeated. Exact literal duplicate I have. So by default, the union in Spark core will behave like a union all. Union all means it includes duplicate also. But I don't want it to have duplicate. I'll apply one more function on top of this. What is that? In general, to avoid duplicate, what function we use? Distinct. So I'll be using distinct here very directly. So all the data got union, 8 rows I got. Now it will become 7 row because the Arun Kumar is going to exist only once. So I got how many rows now? I did not get 8, I got only 7 because I performed a distinct operation. Now it becomes what? It becomes union. It is not union all. This is union all, this is union. I hope you are with me, guys. Right? But we have to understand more about this union, not in the perspective of Spark core. Not in the perspective of Spark core. In the perspective of SQL, we have to understand. This is a interview questions everywhere asked. What is union, union all? What is the difference between them? If I give you 2 data sets, I want to combine them and store it into a single data set. How do you do? Like a lot of questions may be asked. And this kind of examples also I have given in our hackathon. I'll give you some 2 data sets of different insurance companies or insurance data set, insurance info 1 and insurance info 2 I'll give, and I'll ask you to remove the header and then store all of them together, the insurance info 2 together, right? After applying some data merging activity I wanted you to do, data deduplication activity I wanted to do. These are some terminologies, but these terminologies will really help you to apply in the business, in the interview and all. Can you tell me some technical activities what you did? If you say I do data merging, I do data melting, I do data collection, I do data deduplication. Like if you talk about some of these terminologies, not limited to. This is one way you are going to apply the data engineering activities. We are yet to go there. But the only thing is people don't have patience. That's the only place I used to always worry, basically. Maybe hopefully I can see, when I go to this Power Core or this kind of bit vague part, right? People lost their interest, but it's not the case. Always we should not look for some creamy thing. We have to look for both the things. If you know the pain of all this, then when you go to the creamy layer, we will be feeling more comfortable. There we are going to see a lot. Okay, fine, let it be. So just I have touch based on this, guys, right, up to union. You go through and come back, especially people not from the SQL background. I will cover a bit more into this union or intersection or whatever the concepts, but we have to split this data and see. That is where we really understand the way how the union works. But without splitting also we can do. But after splitting and converting into respective tuples and all, when you go and apply this union, you will see a lot of pain. You could not able to union as like how we did. So let's go and see that part maybe in the next week. So have a good holidays, festival and weekend, guys. Okay, we'll meet on Monday. Any questions?
Irfan,
So,
one question, Irfan.
both are same in, sorry, Irfan Vijay here.
Go ahead, please.
Union all both are same org.
Both are same, but union is the only thing what we have in Spark. We don't have union all. The union will behave like a union all. What does it mean?
It accepts duplicate.
It accepts, it stores or it returns duplicate also. Do we see duplicates here?
Yes.
But whereas if you want to achieve union means what? In SQL we have a function called union as such.
Yeah, of course.
It will deduplicate and store the result or produce the result. In a deduplicate fashion, it will produce. You got my point? In order to deduplicate the data, we have to use distinct here. To make this union as union in as like SQL, we have to apply distinct on top of this. Otherwise, it behaves
as a duplicate record.
Otherwise, it behaves as a union all.
Okay.
Yes, case sensitive. It is case sensitive, and it's not like just you can say it is case sensitive or not, and all. We can address that also, but it is case sensitive. Literally, it will look for each and every values. If I open this file and say Arun Kumar having small a, Now when I apply this distinct even, it will return how many rows? 8 rows. Got it, Venkatesh? Is it case sensitive? Right? It's case sensitive. Yeah. Anything else, guys?
If we were relating DAG when we were discussing about map partition, I missed that.
I'm not getting you. Okay. In the DAG, you can go and see. It is showing map partitions only, though I did not apply map partitions. I just only applied map function. The map function will go and run internally the map partitions only. So I did not wrote that function called map partition. He internally does that way. That's what I told.
Okay, that is why we were talking about DAG.
Yes, that is where I shown this DAG action. This DAG I have shown to make you guys show this. When I hover here, it is showing something called map partitions RDD. Though I did not wrote anything related to map partitions in our Spark program. You got my point? So that proves what? Internally, the Spark will use map partitions. So I don't have to worry about using that map partitions concept externally. At times I have to use them. You got it? When do I use? If I want to explicitly control the partitions. Basically, Spark will take care of iterating at the partition level only. But we feel like I got iterated at the element level. Right? Any other questions, guys?
Yes, Irfan. Bala here. Can you go? We are speaking about the tuples, right? Tuples, array of tuples.
Yes.
Can you have shown us the class case class, right? Can you just show that example once again? Because naming with the naming.
Yeah. Case class, I need to still go.
Yeah.
See, very direct. You keep some data into a tuple. Okay. 1, Irfan inside a tuple. This is a tuple. Very direct. Very simply if you want to learn. I can access this by saying what?
The
Dot
position.
underscore 1, dot underscore 2. I don't want it to access by this way. I want it to access by mentioning the column name. So I'll create something called case class. It's a class only. First, like this, I'll create with ID first column as integer and the name as string. Then I'll do what? When I pass this tuple, I'll pass that to the case class. First, I'll say, hey, tuple, can you get applied to this case class? So I have to talk about this formally by speaking in a bit different angle. I have to take you guys to a notepad and I have to take you guys to an Excel sheet and I have to convert this notepad data to Excel sheet. At the time, I have to go and put each and every column with the respective data type like this. And I have to apply that column. When I copy the data from the notepad to the Excel sheet, I will apply this transformation or with this column name and the data type over there. And then if I show, that is equivalent to what we are doing here. If I show in that way, you will not forget. But that is not the part yet I went. So let it be. Now I can access by name using like this. You are with me?
Yes, Irfan. Get you.
Got it? So we got
Just we are assigning some data
record.
and calling it via the names we have, means the inputs.
Name and the type. Name and the type.
Yeah.
Yes. Got it?
Yes, Irfan. Thank you.
Because when we go and write a SQL and all in Spark, it needs the name. I can't just give the column position and all, always, right? In SQL, we give the proper name. So this is like equal to, we are loading it into a table, kind of. Like an Excel sheet, kind of.
If I have in an RDD or something array of, instead of this individual value, I need to, for each of this one, I need to pass that to the entire.
That's it. See, rather than taking a separate record like this, we are going to pass it to a, in an RDD, if we have, we are going to pass through a map function.
Map function. Okay.
And the map function, what I'll do, rather than calling like this, I'll call it inside a map function. I'll say first element of the array and second element of the array you take and pass it to this case class. Apply that to all the records in the case class like this also. The reflection terminology I used, right? Why that reflection name has been come up? Because I'm going to pass each and every row to the case class and get it reflected. I'll see the reflection of the case class applied schema. Got it?
Yes, Irfan.
We call it.
Can you come again with the reflection? Sorry.
Reflection means what we do. I just go and pass my 1, Irfan to the case class of customer and get it reflected by applying the ID and the data type to it. That is called reflection, right?
Yeah, passing some value and getting some
Getting
same
something else reflected.
Yes.
What is
same.
reflecting? It is applying the column name and the proper data type and returning back. Structure schema full RDT and created. Got it?
Yeah. Thank you.
All about it.
Hello.
But don't worry about this part. We'll be heavily seeing this in the Spark SQL. That's the reason I just on and off touching this. Yeah. Yes.
Irfan, we were discussing about map partition. So the DAG graph which you are saying is we are establishing a connectivity for bringing the text file, and that's why the map partition have come into picture here, right? In this case.
I'm sorry. Can you repeat this?
Okay. So here, we are bringing the map partition. I mean, the map partition in this DAG graph is seen because we are getting the text file from the external location, right? That's why we are.
Why map partition is coming? If you do some mapper operation, I'm doing some mapper operation here. This map will internally go and run inside the partition only. For me, what I'll say, the map went to the first line of this line's data and converted into array of string. Second line it went converted. Third line, fourth line, fifth line. That's how I say. But what internally it happens is, I don't so far thought about something called map partitions. But anytime you write a mapper program or anything, it goes and apply at the partition level. If I want to reach here, very simply, if I want to reach this data, what I have to do? I have to cross this partition. In order to cross a partition, what function I need?
Map
partition. Map partition I need.
Partition.
But did I mention anything like map partition here? I wrote only a direct map method.
Okay.
This map method will go and take each and every element and process at the element level. But explicitly, before this map, if I have to apply this map at each and every element level, it has to cross what first? See, I have the data like this.
Map partition.
Stored in an RDD inside a partition, it is stored as data set like this. If I have to reach this data, I have to cross what?
2, which is partition.
Partition. But I did not talk about it so far with you guys other than the map partition concept. What internally it does, though I did not speak also, it will cross the partition automatically in the behind. Now what I spoken here is, the map partition, what I spoken here is, you don't cross the partition, right? Like this. You don't want to Spark to automatically cross this partition. You want to take a control of crossing this partition. So you can stop at the partition level and you can pass your subsequent function inside that. Rather than directly passing line start filter, you pass it inside the map partition. So you manually go and take it inside the map partition. Like this I'm telling. So we can achieve the same result by doing this both the ways. Do you agree?
Yes, Irfan, but yeah.
This way also we can do, or this way also we can do. What is the other way we can do?
Map.
Like this I can do, not map. We can do by this way also. I can say filter of L tends to L dot length greater than 20. I can write this direct filter over here itself without going with the map partition. Both are going to produce the same result or not? Both are going to produce you the same result. Are you finding the same result in both the cases?
Yes,
I can apply the filter, or I can go at the partition level and apply the filter. If I directly apply the filter, what it does in the behind?
It goes through partition and then
It will automatically create this outside loop and then it will go inside the inside loop of this filter. Now what I'm telling here, guys, we even can take a control by using a function called map partition to control that outside loop also.
Okay, I got it.
Got my point? And in that outside loop, if you want to apply some BB connection or anything, you can apply as well.
Okay.
That's it.
Yes, I got it. Yeah.
So, however, we have to cross this 2. Without crossing this 2, we can't reach this 5. Whether we are going to manually mention a map partitions and then you are going to the lower level, or we can directly apply the function at the lower level. It will cross map partition only in the behind scene. That's the behind scene of what I'm showing here. Even though I did not use this function called map partition at all, I did not apply this map partitions at all. It still used the map partition only in the behind scene. But if you want to take a control of that, saying, hey, no, I wanted to explicitly apply that. Apply, no one is going to stop us. But in what situation we may apply? Not in a regular situation. Regular situation, we prefer lighting like this. But here I want to do something before going into the filter level. I can do something over here by taking this iterator. This iterator is stopping at what level? I'm getting this
Partition level.
which it stop at the partition level.
Partition level.
This incremental stop at what level? The element inside the partition level. So now you have a control of X to go at the partition level or L to go at the element level. Whereas here we have only
The element level.
at the element level, not at the partition level.
Okay.
Huh?
Yes, sir. Basically, these are all used for the performance benefits, right?
Yes, performance benefits, but nowadays we are not using much of this, but for an interview perspective and all, they'll ask about your internal way, how it works and all, if they wanted to know, right? Though these are all going to be used indirectly, not directly by us. Got it?
Irfan, in this example, it is not even going to have a difference in performance, right now, Irfan?
No. This example is not going to literally have any difference in performance, but when you have, if you go and connect with a DB or some external cloud source to process 1,000 rows, let's assume 1,000 times this filter will go and each and every time the filter iterates, it will go and connect with the DB or the cloud source 1,000 times. But whereas here, if I have 5 partitions, 1,000 rows are split into 5 partitions. We can say at partition level itself, you go and connect with the DB, not at the filter level. So that you will have a performance improvement.
Yeah, got it.
Got it? But this way, we don't improve the performance. We don't even answer by this way saying, guys, you know, like I wrote a filter function or I wrote a map partitions to go at the partition level and connect with the DB, because that will be taken care by us in the Spark, SQL and other framework what we are going to see, which will be efficiently handled than what we handle manually. What Apache is telling, don't manually write these functions and all. Write it as a var class, I will do a filter in the behind, right? Write it as a data frame, I will take care of connecting at the partition level with the DB. Like this, he's suggesting. But they will also write a map partitions in the behind to ultimately connect the DB. But they are telling you don't have to write. Got my point? Even we have that luxury, but that luxury we are yet to do.
Okay. Yeah, got it, Irfan. Thank you so much.
Okay, yeah. Any other question? Collect is used to only verify the outcome of the transformation action immediately. Any other use of collect? Is it best to use REPL alone or not Eclipse? Okay, Venkatesh, collect is a different ball game we have to discuss. In order to understand about collect, you have to understand this architecture. I told some time ago, if you remember, right? In order to understand how the collect works, we have to understand this architecture first. So the data from this worker nodes or the data nodes will be collected in the node where you are running your Spark program, where you started your driver program. So I got to make you understand what is driver and everything. Then only I can able to make you understand what is collect. So collect is nothing but equal to what? You guys are all, I gave you all the work to you. I am sitting in my machine, in this computer, and I gave the work to you and Sham. And I'm asking you guys to do some portion of activities on that work that I assigned to you. After you completed that work, if you just do a printing of that output in your screen, you can able to see the output. But I want to see what you did means, I'll say I want to collect and see your result. So you guys will be sending that result to me. That is what the purpose of collect basically. The collect is used for that purpose. It's regardless of Eclipse or REPL, that is a different story. You can use both the places. In Eclipse also we can use collect, but collect is not just for printing the output in the screen. That is how the wrong understanding everybody will have. I'll correct that understanding. I know that is currently not understandable by everybody of you, but if I talk about collect, it will complicate the things you could not able to understand. After collecting, I have to do an iteration on the collected data. I'm going to collect this data in my hand as an array output. Well, collected result equal to something like this I'm going to run. So I got a collected result variable locally created in my computer, which collected all the data in a distributed fashion stored across multiple nodes. In my computer, in a variable, it got collected of type array of string. Got my point? If I wanted to print this output, in the REPL, it is showing like this. In the Eclipse, it won't show the output and all, it won't show. It will just say, I created a variable Irfan by collecting the data from all the nodes. On this variable, I had to do an iteration again by using some function like for each and all. And then I can just do something else on top of it. X tends to println of x of 0. Something like this I have to do here. Then only I can see the output properly. If I directly print the array, it will show the address. What and all, I'm yet to speak with you guys. When we go to the collect here, I'll speak about it. Until I wanted you to wait. Here I'm directly going to talk about collect only when we go to the actions. But I have to cross this part, then we'll go there. Okay, no worries. We have only 1 or 2 days to go to that part. Okay, fine. Anything else, guys? Any other questions?
Irfan, one question. You said Eclipse, right? Is there any other tool for scale-up programs, right?
IntelliJ we have. We have IntelliJ. IntelliJ.
Okay.
IntelliJ. So I will make you guys set up the Eclipse in Windows also soon. Okay.
Okay, fine.
Fine.
And one more question on this map partition, right? Like, is it like a basically used for the performance, or like it's not only like why?
Only for performance, nothing I can do on the map partition. At partition level, what I can do? Nothing. Other than connecting with some external sources at the partition level, I'll use this map partition. Other than that, I don't use this map partition because I have to go at the element level to do any operation. Partition level, I can't do anything else. Got it?
Oh, okay, fine. And one more, Irfan, like the tuples are there, right? Like when you gave the example as employee name and the salary, right? If we have more number of columns, right? It will be difficult to identify, right? Which one to integer and all, right? To convert, right? So how is there any easy way to do that?
No, just think like this, right? So easy way to do in the sense, if you want to say, hey, I don't want to understand any data type and all, it has to automatically do that work. If you want to say, you can do that very simply. How? You have some data like this, let's assume. It's all about matter of patience. You have to wait. I'll be showing all this simple way of doing also, but your question is a valid question. At cases, we have to apply the columns where we don't have any reference for that, means we have to apply. The same question, let me ask you. You are going to load some data of 100 columns into a table, right? In a Hive table, you have to create the columns, right? You have to sit and create the Hive table and mention the columns and you have to create. You can't say, no, I don't do, sit and do that. You got my point?
Yeah, that is correct. Like what I'm asking is, right, when we're reading it, right, when we are converting using the map function, right, like we have a lot of columns, right? So it will be like everything, like we have to go one by one column and then convert, right? That is how we need to write, or is there any other way we can write it to make it into tuple? That's what my question is.
Okay, you see here. You see here. I have some data here, right? So you want to see this data like this. I did not mention any column name. Did I mention any column name?
Oh, no. Okay. Yeah.
or any data type. But you can see
No.
But you can see it is taken with ID, name, and the age, right? Or I have to mention something like infer schema true or whichever. Okay, whichever is fine. That options we can mention. I'm going to tell you, hey, Spark, don't ask me to do anything. I'm telling you got to take care of doing all the work. One second. So it is doing what? ID, it is identifying as an integer. Name, it is identifying string. Age, it is identifying as integer, and it is displaying everything without I mention anything. My work is just writing this one line of code. This is the simple part what I made to show you guys. That is where I'm telling people don't have patience. I'm not talking about you. Somebody don't attend the session by thinking like, hey, Spark is like this. You can just do this to write anything on top of it. You can write a select query. Am I writing a select here? Did you see that? Did you see that? I can write a select query directly. I can write any queries on top of this directly. So
Okay.
that all is the next part of our learning. This is what the bread and butter of your learning actually, what I'm speaking, right? But you can simplify your life. Did we do anything? I'm telling you, Spark, your work is to go and identify the schema, infer the schema, whether it is an integer or string or whatever. Your work is to use the header of the data to identify the column names. I feel a bit tired to type all this. You got it? You can do.
Okay, got it.
You can do as you asked as well, but that is not the always case. Okay.
Okay.
We have
Thanks,
all-
Irfan.
Okay. Yeah. Anything else, guys?
Irfan, I have one question.
Yeah.
Shall I share my screen? I just tried this one. Can I share this?
One second. I'm trying to give you the access. Yeah.
Yeah.
You can share.
Maybe out of trying only I did it. So what I'm doing is I'm having a. Are you able to see my screen?
Yeah.
I'm just getting these lines. Okay, I have getting this one. Okay, I'm getting the array of string over here. Okay, what I'm trying to do is I'm assigning and splitting and getting only the first two here. Okay, as part of this one.
Okay, first column and the second column.
First column, and yeah, I'm getting to just get this one in the upper and the employee name and the city only. I just want to put it. Okay, so I'm just getting it. Either I'm directly collecting it or I'm not. I'm just assigning it to an RDD. Okay.
Okay.
Here I'm getting an array of tuple. Okay. Again.
Yes.
Okay. If now I actually created a one employee class and employee thing. Okay. Where I just case class I tried it.
Okay.
1 second. How can I get that 1 second? Case class I will.
No problem. Tell me, you created a case class with two.
Yeah, with the two string. Yeah, integer. I want to get this. How can I get the employee name alone now here for all these things? Because when I'm getting it, it is not giving. I tried is emp.l1. Okay. So
No. 1 second. See, as such, I told you yesterday, we can't just directly go and access the RDD elements by giving off 0 off dot L1 or anything. You go and run that above line, the L1, or give L1 dot.
Collect here.
Whichever is fine. No, don't do collect. Wait. When you do collect, it will show all the records of type, whatever the EMP case class. But you did not apply the EMP case class yet, right?
Yes.
Apply first the case class. Put an up arrow.
Yeah.
No. That L1.
Yeah.
Come left side. Just scroll left side. Move your cursor left side.
Yeah.
Okay. Go after map of x tends to. Second map.
Yeah.
Tends to.
Okay.
Before this. No. Wait. Yeah. No. Just stay after the greater than symbol. X tends to.
Yeah. Okay.
Type EMP. You are going to pass the each and every row into this EMP or whichever the case class you create.
Yes.
Okay, now you type enter. It applied that case class. That's it. Okay. Now you are going to put up arrow once again. You put and type dot.
EMP dot, right?
No.
Yeah. Tell me. Now you tell me. Up arrow.
Just put one up arrow. That's
it.
That's it. Not this one. The map one. What you have created. The EMP one. What you applied, right? That one. Which one?
1 second. 1 second. Yeah, this one. Correct.
this one.
Yeah.
Dot.
Okay.
You are going to take the particular element by mentioning the column name. That's what you wanted to do.
Yeah, yeah. I already
Map
created
again.
the
Map also you can do, or for each also you can do. Let you do a map. Okay. Map of
Okay.
extends to
yeah.
extends to x of extends to x dot.
Okay.
Whatever the column name you mentioned. You mentioned as name or what?
Name.
Okay. Now you give dot collect or whichever.
Yeah. Okay.
You wanted this one only?
Yeah, yeah, yeah. So I just wanted to refer it by the name and I created.
Yeah,
and
you are going to perform an iteration on the data because it's not a one record. It's a multiple rows. It is going to have.
Correct, correct.
It is an RDD. So you have to use some function like map function or flat map function or some function to access that RDD.
Okay, so here I am getting the data. In here I am passing the value to my this one.
Yes.
Okay.
When you are creating a tuple, you are not creating it as a mere tuple. You are applying that to a case class, and you are creating it as a schema RDD. We call it as a schema full RDD. You are creating a schema RDD here.
Okay. How I thought is I created an RED. It came as an array of tuple. Okay, so I can directly pass that one. Though even I'm collecting here and I can pass it, but
You
I
can
won't
do that also. I'm telling you can't. Can you put an up arrow? Don't give this map of city and all. Just remove it.
Okay.
Just give collect here. Dot collect. Okay, you got it collected as a normal L1 of type EMP, right? You got the L1 created. Now give L1 dot or L1 of. You have an array of elements here, right? So you had no, wait. L1 of.
Okay.
0 you give.
Okay.
Now you type enter. You got the employee type of Arun Kumar and Chennai. Now give a name.
Yeah.
You got the.
Yes.
So if you access one by one, you have to access by this way. Or if you want to iterate again on all the rows and you want to collect all the names, what you have,
then I have to go
or Lara, whichever you want to collect. Then you have to go with one more map and do that activity. If you want to you go with map. If you don't want to do, you just go with direct value itself.
Okay.
But you have to collect into a variable and then you have to do that if you are going with one element alone without using the transformation function. If you wanted to see the data of the RDD, you have to collect it.
Yes.
You are trying to see the output by keeping it in an RDD itself. That is not possible because RDD is not materialized. First, it has to be collected and then materialized. Then the materialized data in a variable you can access.
Okay. Earlier, what I did is I did not pass this directly here. I collected till this one. Okay.
You can do that also. What you are telling is also you can do. If you want to do that way, you can do as well. Not a problem. But
I actually
you do that way. Yeah, you just do this. No, don't put dot city and all.
Yeah. Sorry. So I tried this one. Okay.
Yeah,
I was able to
have. You can still do that. You want to apply now the that employee. You can apply.
Yes.
L1 dot.
Pardon? L1 dot.
L1 dot.
Yeah. Okay.
L1 dot map of you have to apply. Or you take the element, first element you apply the map. You want to apply only for the first row. You take L1 of 0.
L1 of 0. Yes.
It is going to return a tuple type, right?
Correct. It will return me a tuple. Correct.
Yeah, it is going to be a tuple. You have to mention instead of L1 of. You just mention like this. EMP of 0. One second. L1 of 0.
0.
1 second. Okay. Just type enter.
Yeah, I'm getting a tuple.
Okay. Now you give EMP of L1 of 0.
Got it. Yeah. Actually, I was expecting this one. Okay, now I am understanding of 0. Yes.
1 second. So it is not directly considering that object. 1 second.
Yeah, this was the error I'm getting. Is an
okay, give like this. Just give like this. EMP of within bracket, one more bracket you open. Bracket L1 of 0, comma L1 of no, L1 of 0 dot underscore 1, comma L1 of 0 dot underscore 2.
Okay.
Of 0 dot underscore 2. Put a bracket close.
Now I need to put one more closure, right?
One more. No, not. You had to
correct.
in the one more bracket. Yes, you have to put.
Yes.
Enter. 1 second.
This one is
Can you put alone of 0 dot underscore 2 just outside? Just come down and put that one. Just type. You remove this and type. Not EMP. Just type
okay, alone of yeah.
0 dot underscore 1.
Yeah. Yeah.
Okay. So you passed it inside a tuple. Okay, just
Right, this one.
without passing to EMP, can you pass that into directly? Can you remove this? Can you delete this?
Okay.
Can you copy that? Remove that EMP in the above statement. What we have above. Yeah, there you just remove the EMP. Yeah, just copy from there. Yes, just copy till the last.
Yeah. 1 second.
Remove
This one, right?
Yeah, just type enter.
Okay, I'm getting it.
Okay, you are
Yes,
passing.
yes.
Okay, can you store it into a variable? Or just give EMP of res 140. EMP of res 140.
EMP of res
149. The variable above.
Yeah. Okay. Res 149. Okay. It should actually give me, right? Actually, this is how it is for. Okay.
1 second.
String of so user you can pass in this one. It is 20. In this case, being like class under this part.
That's where I wanted you to convert.
Yeah.
Okay, you do one thing. In the above employee statement, you would take that employee, the top one. Yeah, above one.
This one?
No. Go above. Just put your up arrow to 2, 3. Wait. Here you remove that outside bracket. Yeah, try this.
Okay. Now, okay. Yeah, I know. Yeah.
We don't have to do it, but
yeah. I get it.
Obviously, for learning purpose, this is how you can play, and you don't forget this tuple.
Yes. That's I get you.
This is what I wanted from all you guys. Just try this once and come. You can able to learn everything. The Spark core is all surrounding this.
What I'm trying is, I'll try it, Irfan. These are some small things I will do. Thank you so much, Irfan.
Okay, yeah, thank you.
Yeah.
Fine, guys. Thanks. We'll meet then on Monday. If you don't have anything else.
Thanks, Irfan.
Thank you, all guys. Bye.
Thank you.
Thank you.